Good evening, everyone. I hope my voice is loud and clear. Perfect. Thank you. Thanks for the confirmation, Gijo. All right, so I guess it's time and we can get started now. So last week, we sort of discussed about these different methods. We were started the scope knowledge area. And in the scope, we have a scope management plan, which is primarily nothing other than a set of guidelines and rules, which tells you how that scope has to be, like basically how you have to manage that. So which talks about what will be the methods of collecting the requirements from the customer, basically the methods, which is what we're looking at here right now, different ways. So as an organization, we will have already decided, like there are protocols which we follow, how to collect the requirements. You might be conducting a survey to collect requirements. You might be having a brainstorming. You might look at historical documentation. You can do a focus group meeting. You can do mind mapping. You do like all these things. Bottom line, the options. So as your company might have already decided certain rules, which will be documented in your scope management plan, which tells you that these are the procedures, how you should collect this requirements from the customer. Now, when you collect the requirements, where do you document that? Well, it's a like paper or like some sort of documentation with like a or like you do a physical paper, or you probably want to do it electronically. Whatever the methods will be documented. Then how you translate that into a requirement traceability matrix. When you have the requirement traceability matrix, how you sit down with the team and create a project scope statement, and then how you go about and further break it down into a work breakdown structure. And practically, when you like, basically, it's all about the rules and guidelines. So the activities, the task we're talking about is collecting requirements. So we talked about these requirements, different methods of requirements. There was one slide which was I said like it is misplaced, and actually it's misplaced. So again, we quickly go and move on. Like these are the things which we discussed last week, the last thing we were discussing. So this slide will come back again. That's not this one, but these are the same: interviews, questionnaires and surveys, observation, focus group meetings, facilitated workshop. We discussed about these, yes, last week. Benchmark, we discussed about that. This slide was the misfit, so we'll be discussing this. But again, quickly, let's just go through mind mapping, affinity diagram, the context diagram we talked about, and then I guess the prototyping. Yes, the prototyping, the storyboarding, and that was the last thing in the list. And then you have a scope management plan. So before we go to scope management plan, let's go back and refer to that slides. The slide which was a misfit in that one. Well, it should have come in the end, like not right now. So not in between different, like you're talking about different examples, and this is like in between. Ideally, it should have come after the mind mapping. Any which ways, doesn't matter. So while you collect requirements from the customer, and every requirement of the customer has to be like satisfied. But again, you can't just go and work on all the requirements at the same time. You need to have some sort of prioritization done. Well, this will be my first requirement we'll work on. This is the second requirement we'll work on. So there has to be priority. Please keep this in mind. We are not saying cancellation. We're saying priority. That will be, so you got 10 requirements from customers. So we'll be saying like the first requirement will handle this one, second this one, third this one. So that is prioritization. We're not talking about we'll do this and we'll not do this. That's not the case. Prioritization. And how do you do that? There are 4 different methods applicable here. It talks about these methods are applicable for predictive also. These methods are used for hybrid methods also. But if I talk about, like, let me kind of quickly talk about these 2 methods to start with. One is called a Moscow analysis, which is primarily in the software development only. So the hybrid part, the agile part of hybrid, that's where they'll be using this. It's in primarily in the software development. People like they use Moscow analysis. This is generally a qualitative analysis, discussion based. You, me, we all like people will sit together and prioritize the requirements. Based on this, we might want to pull the item from the backlog. So we have a backlog. We want to pull the item based on the requirement prioritization. We can do that. So that's one way we can do. It's qualitative, discussion based. Kano model is something which is like, so you say Moscow analysis and Kano model, they're 100% same. Well, developed by different people. This guy was different one. This guy's different one. But honestly, this is 100% same with small bit of changes here and there. But the big change here is this is qualitative and this is quantitative. That is the biggest change here. Why? Because, well, if you go and search for Kano model, like in general, if you Google up or you will see it's always done qualitative way. The way you do Moscow, same way you do qualitative, but like this discussion based. And Kano model is not supposed to be done that way. People use this Kano model in research and development. So globally, when you see a new car coming in the market, a new mobile phone coming into the market, that's all going through Kano model. This is how actually the prioritization done are. Like when you say iPhone 15 got launched, and well, when iPhone 16 will come in the market, well, they will not change everything. They will change something, probably camera, probably battery backup, probably some features. Bottom line, they don't change everything. How do you decide, well, the next rollout, when you launch a new one, well, what will be the things we will work on? So prioritization is done based on Kano model. So this is quantitative one. Typically, from a predictive perspective, whenever you're doing experimentation things, it is going to be used in those scenarios. We will not go into those details, but again, because that's more into the Six Sigma side of it. But I'll quickly kind of like give you a quick perspective. I'll show you because one of my participants, he happened to be from research and development and wanted to know how kind of model can be done. So I have a document I can share with you, but we can't get into those details because that's like not a part of that's out of scope for us. Paired comparison, 100% from the agile perspective. 100 points method, again, from agile perspective. So only one part, which is, say, Kano model, is typically used in a predictive kind of model. But apart from that, they're all agile related. So let's kind of first talk about what is a Moscow analysis and try to relate it with Kano model. So this is discussion based. When let's talk about, let's say, we have a mobile phone. Let's talk about a mobile phone. I have a mobile phone. I want to understand the features of mobile phones. And there are a lot of features which are there. So Moscow analysis, M stands for must have, should have, could have, would have. That's why you say MSCW, which is must have features, should have features, would have features, and won't have features. So these are the Moscow analysis part. So whenever you start with the features of like all the features you see in a mobile phone, first of all, we talk about the must have features. These are critical ones. These are critical ones. Please keep this in mind. If you do not have this feature, your phone will be a dummy. That means having these features are critical. Not having this will make your phone dummy. They are so critical one, must have. Without that, your phone will just not work. But unfortunate part about this must have feature is that if you have, like there are a lot of must have features like calling, like you should be able to make a phone call. You should be able to send an SMS. These are must-have features in a phone. For you will call something as a phone, at least when I can make a phone call. At least I can send an SMS. That's what we call as a mobile phone, practically. So I may have a 100 megapixel camera. I may have, like, say, 30 days of battery backup. But if I can't make a phone call, it's no longer a phone. I may have excellent, like a software functionality, God knows what not. I can't send an SMS, it's no longer a phone. So these are those features which are bare minimum features which must be there. If you don't have them, your product or your service fails. These are critical ones. And you know, the irony here is having these features will not excite the customer. But if you don't have these features, customer will be seriously disappointed. So these are called thankless features also. Well, when you go out and buy, like, so because they are called like implied needs, you understand, you expect these features will always be there. You don't ask for them. These are expected to be there. Will you go out when you want to buy a mobile phone, you go out and tell this guy, give me a mobile phone with which I will be able to make a phone call or I will be able to send an SMS? No, they're expected to be there. Well, if you have these features, like you're able to make a phone call, you are able to send an SMS, you're not going to go and tell this guy, well, great. Well, I've got a phone and I can make a phone call. I can send an SMS. These are expected to be there. Well, these, if you have them, there is no excitement. But if you don't have them, you will be the most like irritating customer here, like pretty much for them, because you will be irritated here, you'll be dissatisfied, like because it's just not working. So must-have features are those features about what they are the critical ones for the product or service. If you have them, customer is not excited. If you don't have them, customer is seriously dissatisfied. And yes, as far as these features are concerned, we really want to make sure that yes, any company, whenever they look for, they always ensure that there should be no complaints on the must-have features, because if your customers start complaining about your must-have features, you are seriously in a big trouble, because these are absolutely critical features. You may have everything extra, God knows what not in your mobile phone, but if your customer starts facing about calling or an SMS feature, you're done. These are critical ones. Well, that's what in Kano model we call as dissatisfiers. These are the ones, the same features is called must-have features. Must-have is what we call same thing, exactly same thing, 100%. Now we talk about should-have features. Well, these are those features which are called as competitive features. Competitive features, performance features. These are the features which we definitely want more. I would compare my phone with probably some other brand phone. I will compare with price. I want lesser price. I would compare with the camera quality. I would compare with the battery backup. I'll compare with the weight. I'll compare with the screen size and all those things. Well, so I would, as a customer, I would want more and more of it. So yes, technically, as a company, there is a battle bit going on between all those phone brands on these competitive features. Okay, you giving 32 megapixel with the same price range, I'll give 64 megapixel. Okay, now I see my competition is giving 64, I will give 128 megapixel. So battle between the corporates are actually happening on the should have features, because customers desire more and they are excited. So you give more, they get more excited. They want more of it. So these are those features we talk about, like camera, the battery backup, the weight, whatever, like those things which will make it better. Performance will get better. This is what we call as satisfiers. Well, these are satisfied ones, which we call as performance features, or the should have features are performance features, or competitive features, the same thing. Now we talk about could have features. These are those features which are also called exciters. Exciters, which we have here, delighters, exciters are same thing. So these are those features, well, if they are present, they're not going to make a big difference. But they're also called as generally feel good factors. Feel good factors. Well, these are the ones which are not a big differentiating factors like a feature or functionality, but will you just try to do it just to excite the customer, delight the customer? You just added something on top of it. Well, the customer, it's not a big deal. But again, you are able to utilize that. Like in your mobile phone, like we talk about WhatsApp, you have a option of setting your DP, your profile picture. Well, you can do that. Is that a big feature? No. Well, it's a feel-good factor. People can keep on changing it. It sort of gives them like excitement, feel-good factor. You can write down your status. Well, you can write down status and show, well, practically these are the emojis that you have for the feature. That's not a functionality that's a big deal, but it's more about excitement. If you give them, the customers will be really excited and happy because something else to play with. And that's what we call as delighters and exciters. Then certain features are the ones which we pretty much say, well, if you have them, well, customer is not too happy about them. And if you don't have them, still customer is not too happy. Like, bottom line, doesn't matter. Whether it's there or not, it doesn't exist. So why even waste your time in working on those features where customer is not even happy or dissatisfied? It doesn't matter. You give them, they're not happy. Don't give them, they're not like this status quo remains. And that's what we call indifferent features. So indifferent features are the ones where customers are not excited. So companies will slowly, steadily take those features out of the product because it's not helping. Well, if it's something which is exciting, I would like to continue. Something which is not exciting, I would so practically, it's just a burden. It's just an unnecessary element. I'll just probably get it removed. So won't have features are the ones which I don't want to work on because there is no excitement left. So this is ideally going to be a discussion based within the team. I'm talking about Moscow. But again, people do Kano model because if you do it discussion based, you call Moscow or Kano, it's the same thing there. But typically, Moscow is done based on discussion. The team experts can get together, they have a discussion there, and they'll try to understand the critical features, the should have features, which is the could have features and all that. Discuss. And if you still do the same job and call it like based on Kano model, technically you're doing a Moscow and calling it Kano. That's how it is. But Kano model is very different. Ideally, job is same, but this is discussion based and this is quantitative. Quantitative one, as I said, we can't get in there. But if you are interested in that, I will definitely be able to share something. Not like we can't get in the discussion right now how it's done. But yes, if you want to know how Kano model works out, because they're same technically, the only difference is it is the quantitative model. So I have only one video recorded on YouTube, which is kept unlisted. So if you have this link, this is about 17 or 18 minutes long video in which we've done this kind of model sort of analysis. This is what I have done. There is a software we use in Six Sigma called Minitab, and I've done it on Minitab. I've done it on Excel. Using this blank Excel, and I try to kind of create how whenever a new product is launched in the market, like iPhone 15 got launched. So companies would have started doing the survey through various portals, customer service centers, journal surveys, stuff is collected. So how they go and collect this information, what kind of feedbacks are collected from those customers, and then based on the feedback which is collected from the market. So we're not sitting and having a discussion. I'm actually looking at the voice of customer. I try to capture this information, the sentiments of the market. I will capture this information, and I want to understand the sentiments of the market, not have a discussion here, but understand the customer sentiment. So there's a formula, there's a table basis which it's done. You get some score generated based on this formula, and then you get to know which of those features are must be, which are performance ones, which are attractive ones. So you would definitely want to make sure if their complaints are about must be, you have to take care of them. So again, the entire thing has been discussed and explained in that video, about 17, 18 minutes long video. You can open up this link of the YouTube. If you're interested, just check them out. I can share this in the notes. So you can see I've done this on Minitab on an Excel. Try them out if in case you are interested in understanding how Kano model works, the quantitative model. This is not discussion, all about some scoring, numbering method. So same has been done because some people may not have access of Minitab. So I've done it in Excel also. So you can try it out, because this is how globally the corporate world, research and development, when they try to come up with the market survey is evaluated, is tabulated, and then based on certain scoring mechanism, you have a formula which will derive the score, the satisfaction score, the dissatisfaction score, and then you plot that to understand which feature has to be prioritized, which has to be deprioritized here. So this is an absolute market sentiment which is captured, and that's how you want to always decide and understand what's trending in the market, and that's how you adjust your product or service. So you know what is the demand, the needs of the market, what is the customers are asking for. You're not having a discussion because you and me can sit down and think differently, but let's understand the customer sentiment. Well, big question is, do you want to serve the customer what you want, or you want to serve what the customer wants? So Kano model is what is actually aligned with the market sentiments, and that's how you get to know. If I have to be the market leader, I have to always listen to the customer sentiments. And again, I should be able to catch up with the market changing dynamics of the market trends. And that's where Kano model comes into picture. So very, very effective, very important model. And yes, the bigger corporates always use this Kano model. And obviously they do it through a practical quantitative method, not a qualitative one. But all in all, that's Moscow and Kano typically will be the same model. Only difference is one is qualitative, one is quantitative. Now, quick one before we get there. Is it okay and clear before we talk about paired comparison and the 100 points method? Quick check on the paired comparison. And my bad, not paired comparison, but the other one. Okay, quick check here. 1 second. I'll be kind of opening. So I will have to go and try to create some exam. Moscow is qualitative. Yes, Moscow is discussion based. Moscow is qualitative model, and Kano model is a quantitative one. But again, job is same. Here you're having a discussion and deciding what is important. Here you're looking at market sentiments, getting a score, and that's how you're deciding which one is important and which was not. So it's better model any given day. More scientific way of doing it, Kano model. But again, both are bottom line, both are used. Now we'll talk about what is paired comparison. For that, I have to take you to some sort of Excel sheet and kind of show you, well, when do you use a paired comparison? That's important to understand. Paired comparison will be used only when you are dealing with like smaller things to compare and see which one should be picked up, which one should be like, I'm not saying that we will not do the other ones which are not like, it's just about prioritizing. You will go with A first or you'll go with B first. It's a first thing, not saying that we are not going to do A or B. Both will be done, but it's just about priority. We'll do it. Do we know you don't have to do the calculation? It's just say, Fatima, that's why I said this is from exam PMP wise. You just need to know what these are. That's it. Again, you just have one piece of calculation that we will discuss on the last day. That's only, and this is a small piece. That's it. It's an easy one. No calculation. like before and after intervention. Ruxan, like here in terms of what? Like I didn't get your question here. We're talking about the paired t-test. You're talking about Ruxana, the before and after you're talking about. Yeah, so no, it's not the. This is before. This is actually we want to understand the markets. This is about development, feature development, and all product development. People use the Kana model. We'll get again. I'll share the file if you want to. Just it's about 17, 18 minutes long video where you'll see everything getting created from the scratch. If you want to watch it out, just good for knowledge again. Like, unless you, if somebody is in is a research and development work, then definitely that's a critical one for you. Okay, let's quickly have a look at what is paired comparison. Yes, Maha, you will be. And they're small pieces. It's not too much, but last day we'll be working it out. I will be sharing this file. Let me just show it you. I will put it to, I don't mind. I'll share it today itself when I'm sharing the file. There is a small bit of calculation. I'll be sharing that. That's the only formula. Not too much. It's very simple. I will share this file. These are some formulas. We'll discuss on last day, because that's when it will come. The content will come. It's towards the end of our training material. It will be in the end, not right now. So I'll share this file. You can have a look at it. Good to read. And if you want to read it out early, we will discuss these on last day. That's all you have in calculation, nothing more. Now, perfect. Let's kind of talk about what is paired comparison. So here again, please keep this in mind. We're talking about priority. We're not saying it's not, we will not do something. So here we have got we're doing some feature development. Say, remember that we have a backlog and all that stuff is done. The team has to discuss and decide, well, which one should be pulled up, because team decides to pull. Well, product owner will prioritize, but the team will pull the item which they believe they can do the job in the current sprint. So how do we go and decide which one to be picked up and which one not right now in priority? So let's talk about, let's create a small table to understand what is called a paired comparison. So when the comparison is between lesser item, this will make sense. Lesser, not when it's too much, you don't do this paired comparison only for small things like small discussion, basic, not too much of complicated ones. Feature E, and let's kind of create here. Let me just copy paste it here. So this is my table, and let me just create. I'm just trying to. I'll kind of go and talk about what is it. Let me just shade some areas first. This is how it will be done. Let me shade it here. While I do this, I'll explain what is it I'm trying to do here, so we're able to relate with it. So I'm just trying to highlight and get some cells out of the picture. Now, this is what we have. So we have some features A, B, C, D, E, and we want to understand what should be the priority. Well, if you have to go and design, develop it, we have to do all of them. But which one should we pull up first? Or probably we are doing it with the product owner also. We are helping the product owner. It's no like product owner decides, but at times it's our job also to kind of educate the product owner to understand which is more important, which is less important. We can work with the product owner. So it's it's more of a process of prioritizing. We have to do all of them, but which one is more important right now? So what we do is we create pairs and we say, which one is more important? We just try to compare two values to whether this is good or that is good. So the team will discuss. Right now we're saying when we compare between feature A and feature B, which one is more important? Like, so do you think whether feature A is more important, feature B? The team will discuss. They're all technical experts. They believe, okay, if we compare A versus B, A looks more important. Okay. So it's a very simple, very lightweight method. So we do two comparisons, paired. That's why you call paired comparison. Now I compare A feature with C feature. Now we say which one is more important, A or C? Now probably when we compare with C, we found C is more important than A, given the needs of what we're trying to develop. Now we compare A with D, and we found A is more important. We do A with E, and we found, well, AE, again, so let's go. A is again more important here. So we did these comparisons with A with B, A with C, A with D, and A with E. This is done. Now we start doing with A with C. Why? Because A with B we have already done. So I will not do this A with B because it's already done. A with B is done here. Similarly, B with B is not B because that's only feature B. So I would not do it. So I'll start A, B with C feature. When I do B with C, I try to see that C is a stronger feature and more important feature as compared to B. So we say, well, we'll still go with C. And then we try to see, well, B feature, when I compare D is more important, D is more important. We figure out, okay, D is more important than B to work on. It's discussion based. The team is having a discussion, which, and the easier part is that we are doing, just decision is to be taken between two. Is this more important, or other is more important? When we compare with B and E, we say, okay, E is more important. Similarly, I'm just going to put it like C is more important and C is more important. And let's say here we call it E is more important. So we've compared two features together. I say which is more important. That's all we do. Now what we do is we generate a score. And what is the score here? So if we look at all the features, which is the most desired one, I see C has got 4. Let me kind of keep shading it together. C has got 4 scores. So C has been winner on 4 occasions. Then I see the next highest is A. A happens to be the next highest one. So A has been a winner on 3 occasions. Then we look at E, and E has been a winner on 2 occasions. And then we see D. D has been a winner on 1 occasion. And E, or rather, E we have done, we've got D, and then we've got which one? B. I guess B never won. Yeah, B never won. So B has never been a winner in any other comparison. So this is going to be my priority order based on discussions. We will say, okay, since whenever we did a paired comparison, this C feature happened to be the winner on most of the occasion. That will be my first priority. Third, second, third, fourth. That's what we call as paired comparison. It's compared between 2 different features here. So is it okay and clear? That's paired comparison. But you only do when it's the elements are less. Otherwise, it becomes messy. You don't do it with a bigger, larger sets. It's meant for smaller groups. Paired comparison, and it's done between the teams. So yes, I guess it will. Small groups, yes, that's what we'll say. Small groups is what we work with. Quick check on this one. If it's clear, paired comparison, we try to compare 2 features and say which is more important between 2. So it's easier rather compare 10 different things. We say this is more important, or other is more important. Is it okay? Agile, yes, because you do the features development, you deal with the agile only, ideally. So it's a hybrid part of agile. Quick check on this one. Is it okay with everyone? We just have last piece, which is 100 points method, to talk about it. Okay, let's talk about this 100 points method. Now, we must have all played the game called Monopoly. Well, I'm sure everyone would have played Monopoly at some point in time. This is exactly like Monopoly. Now we have got features. Let's say same features we get copy paste here. So you got these are 5 features to compare from. And we are trying to understand, well, which feature is more, but we'll have to prioritize and we'll be implementing all of them, but which one to go first? And we got team members. So we got team member 1 and so on and so forth. We got multiple team members. And what we do in 100 points method, let's say we have 8 team members. And in 100 point methods, see, every member has been given 100 points. And they can distribute this 100 points as per their understanding based on what they feel is right. So no, there's no condition. I can go and put all 100 points in one of the feature. If I strongly believe, which is where I feel it's not too good, because it gives the liberty to the person that if I strongly believe, okay, D is more important, most important, I can put all 100 points for D, which is where ideally it is not the right way, but again, that's how it's allowed. So for example, this guy believes, no, all features are equally important. So this guy goes and distributes 20 each. Total points 100. Let me just kind of put it this way. Let me take a sum so that I don't make a mistake with the numbers. So 20. So this guy distributed all his 100 points this way. Similarly, so this guy came up with like some more features. This guy felt that, okay, for this second member, he wants to distribute 40 points here, 0 here, say another 40 here, and say 20 here and 0 here. That's where we're done. So this guy believes, like third one believes this is say 25, 25, 25, and say 0 and 25. This guy believes like 60 here, 10 here, 10 here, 10 here, and let's say 10 here. We got it like this. This guy says 35, 35, 0, 0, and we got like 30 here. Like different people gave different kind of numbering system based on their understanding. They can distribute any points any which ways they feel like. So and yes, I said like this is also possible. Absolutely possible, which is where it becomes wrong. It becomes wrong. But again, any which is you don't decide anything here. Well, we can't decide anything. Like this is like 40 here. This is what we call as 100 points method. You know what will be done? We'll just take a sum. We will see which feature got the maximum point and maximum score from the people who are rating. And who are these people? The team members, decision maker. Remember, Agile, these are the people who take all the decision. So the maximum one is this one. So this will be the first one. This will be the second one. This will be the third one. This will be the fourth one. And this will be the fifth one. That's the priority. So that's called 100 points method, where you play like it's like if we play a Monopoly game. This is exactly like you vote based on, and you can distribute 100 points in any way they want. Like, but if you play a Monopoly game, you are given the fake money and fake currency, and you can buy certain things. Like, I hope we have, at least I know I played it once, so that you can buy certain things when you play that game with that fake currency which is given to you. That same way, the Monopoly game you can deal with it. It can be dealt with larger groups. So paired comparison, when it's not working, you can switch to. But again, ideally, we should draw some sort of rule and guideline about not putting 100 points, because it will change the entire decision. So I guess we can say we can put a rule like you can't put like probably more than say 50 or whatever, 50% of it in 1 point. That's what like 25% or 30%, something like that should be always assigned ideally. But again, it allows this. It allows that either person can distribute all 100 points in one of the feature. So these are 4 different methods for prioritizing the requirements, not cancellation, but deciding the sequence. Consensus, yeah. So people will do it and then finally see which one is the winner. Which one is the winner? Absolutely, yes. Diana, you're right about that. Quick check on this one. These are okay with everyone. Shall move ahead to the next section, which is all about you involve the larger groups. Does this impact the decision making? See, when we talk about larger groups, it will be like bottom line, we talk like different people. When the group size is bigger, it does like, because you are trying to go and have a bigger set of people doing this job. So you may be able to see that this gets distributed equally. So probably one person might have given a lot of emphasis on one. It will get distributed. So it's more about whenever we talk about like a lot of people are involved, it gets, even if one person might have given an extra emphasis on one, it will get worked out. So with larger group, it will work fine. Smaller group, the bigger differences will be shown, will be visibly seen. But with a larger group, it gets even out. Even if somebody has done a very unequal distribution, it will work out in larger groups. Karno model for bigger, I would say Karno model for research projects. Mr. Samad, Karno model for research projects, ideally. Moscow and Karno use, Moscow analysis for software development. Moscow is for software development. Karno is for research projects and typically predictive. Moscow is used for software development. Quick one. All right, so let's move ahead with this topics. Let's kind of talk about the scope management plan, because that's what we will be getting into. So what do we do in a scope management? What about construction? It's predictive, right? So when you talk about predictive part, so generally when we talk about going and prioritizing, here we talk about the features being compared. So here, see, there are small features we're talking about. We're working on the features we can use. And while you're doing it, it's not that I can't use these methods for, these are tools. These are tools for prioritization. Can I use it in, see, typically when you talk about Moscow analysis, well, Moscow analysis will ideally, it's generally been practiced in software development. For that matter, we talk about your paired comparison. It's generally because you compare between 2 features. But these are tools, and can I use this in any industry? The answer is yes. Why can't I use it? But again, you have to customize as for this. So be it a construction industry or healthcare, or bottom line, any industry, the tools can be used. I need to know the merits of the tool. How do we practice that tool? Because no tool is ideally linked with a particular industry, but more often, if we talk about, these tools are used in a software development. But again, tools, we got to understand the meaning or the purpose of the tool. And because these tools are not like made for a particular industry, but yeah, more prominently, they're used in a certain industry. So, well, you can use any of these tools methods in your construction also. It's absolutely okay. You can do that. Okay, quick one here. While we talk about the scope, we review the activities of the scope. Basically, activities will come in later. Why? Because in the scope, you have just the WBS created, and activities will come, the task will be coming in the schedule part of it. So you have a requirements from the customer. Those requirements will be further broken down to project scope statement, which will further be broken down to WBS, which is about deliverables, which needs to be done. That's what we have, but not the task. Task will come into schedule because you'll break down this deliverable in order to complete a like say we have a deliverable called wall. So that's a wall which is deliverable. But in order to do the wall, we have to do tasks like we have to do brickwork, we have to do plastering, we have to do painting. That task part will come into schedule management plan, not in the scope. So our job ends in this WBS only. But again, this will help you to kind of connect because the same WBS will connect with the, like when you create a WBS, it will further be broken down and that will give us the schedule part. For now, it will help us to, because if you don't create this one, you will not be able to develop the schedule also. So it will help you to understand those activities, which we'll see in the future. So while we talk about scope management plan, helps you to prepare the project scope statement. We know that. Helps you to create WBS. Yes, we know that from the detailed project scope statement. Pretty much, we get the requirement, we create project scope statement. From there, we create WBS. This will help you to create baseline. And yes, if it's approved, that will be the final verdict, bottom line. Scope is the work and only the work which will be done. If you have to make any changes with the scope baseline, well, you have to have a proper change management protocol followed. A change request will be required, and that has to be approved by the change control board, and that's how you will be doing it. So every deliverable that you have there has to have a formal acceptance criteria, a quality checklist, which should say, well, what are the things the customer will come back and check. So my team, the quality control team, will audit the same thing. They will call it verified deliverable. When they verify, then the customer will check. It will be called as accepted deliverable. So every deliverable that we have will have a formal accepted criteria, like acceptance criteria, which will be used for ensuring that the process is aligned with the customer requirement. So every single deliverable will have an acceptance criteria there. So yes, I'm not sure why they say can be formal. It will always be formal. I would disagree with the informal. While you can't keep it informal because you have to have, you can't keep things vague. So it has to be like specific what you're doing. Every deliverable will be we will discuss how, when you come back and check this deliverable, what will you check? So that you got to tell me what will you check so that I can make sure when I'm working on this deliverable, my team can ensure that these things are kept in mind. So you don't have to do a back and forth here. So typically, the rule, this is still a scope baseline, is more about scope management plan, just talks about the guidelines, the rules, how it will be done and all that. Bottom line, all you do is collect requirements. You create the requirement traceability matrix. You go ahead and break that down into scope statement, which is project scope statement, which is like massive list of all possible deliverables. And that is further broken down into WBS, which is work breakdown structure, where you have all the work broken down to the smallest unit of work, which is called work package. Work package is the smallest unit of deliverable, which cannot be further broken down. Like I was talking about wall. Wall is a deliverable and smallest unit of deliverable, which is work package. Does it make any sense to say half wall? No. So I've reached a work package where it does not make further logical sense to break it down further. So I will call it wall as a deliverable. So smallest unit of work, deliverable, which will be audited, will be called as like a work package. We'll see that as we move forward. That's pretty much on the scope management plan. But again, we'll see something related to our scope statement. When you say project scope statement, when it's created, what is in the project scope statement? A, the description, whatever this is, the description has been given about the project, because we would have collected requirements from the customer. That requirement will be broken down. So you'll have, in the end, you have a massive document which says, this is what we need to be done. That's my project scope statement we have. So it has the description of what is going to be created here. Acceptance criteria for every deliverable. You would have acceptance criteria. The checklist, the quality list will be there. And all the required deliverables, which is why we have WBS created there. And yes, it will be also talking about anything which is out of scope, which we are not supposed to do. Like if I'm doing a construction of a house, well, practically this house, getting the house done is my job. Well, agreed. But getting the government clearances, getting the municipality clearances, all those stuff, that's not my job. So, well, we would have agreed on the things which we are not supposed to handle, that will be out of scope, which is because when you do in the construction, you might require the government clearances, the environmental clearances, you might need municipality clearances, probably in certain case, police clearances also, bottom line, depending on what kind of job you're doing. So there could be different clearances, and that's not my job. So the sponsor has to take it. So that will also be covered in the scope, that this is not what we will be doing. This is what customer, the sponsor, will take care of it. And yes, all those constraints and assumptions that we have worked with, because of which we have gone ahead and created the scope baseline. So there will be certain things which we are working with. We are assuming that these things will remain same. We're assuming the risk factors will remain constant and all that. So there are various constraints that we work with. And like constraints could be related to your timelines, constraints could be related to risk factors, constraints could be related to quality metrics, bottom line, the skills that you have, because you have certain people who will deliver. Keeping in mind, we are having an assumption that when we need the resources, we will be able to get resources. There's a lot of constraints. There are certain constraints, you will have it documented there. Bottom line, once this is approved, that can only be changed through change management plan. You know that change request. Once you have approved baseline, that will be only updated through change request, and nothing can be done before that. So the scope is the work and only the work which will be done in the project. That's what we have as project scope statement. Some bit of question answers. Have a look at this. Please help me match the following, and you do get questions of match the following in your examination. So let's pick up let me just label it differently so that we're clear about it. Let's call this A. This one, let's call this one, goodness, what has happened here? Give me one quick second. Okay, I got it now. Let's call this A. Let's call this A. Let's call this B. Let's call this C, and let's call this D. And let's call this 1, 2, 3, and 4. Can you suggest me for A, what's the right option? Document analysis. Well, it looks like, so we got most, I'm going with the majority, given that whatever, I'm looking at the messages here, I will go with 3, as most of us have said. I'm looking at the numbers, and based on the numbers, majority, I'm just going ahead with the majority, given the volumes, and we'll check it out whether it's correct or not. So majority has actually said 3, which is derived from the project requirements from existing documents. Makes lot like that. So that's 1. Let's pick up the B option. B1, B will be which one? Okay. Looks like most of us have said more. Again, going with majority. I'm going with 1. Again, going with majority numbers. I'm going with 1. Product analysis. C will be. Okay, going again with the majority, I will go with 4. And we left with expert judgment, which is nothing other than that, because we don't have a choice here. You're not left with any choices here. Let's see. So let's please, if you can make a note of that, let's call it A3. If we can just kind of make a note of this in the chat, because I'm not sure. Because I don't recall what was the answers here. A3, we're using B1, we're using thank you for Mr. Price. Thank you. Thank you for labeling it. Let me just clear this mess, and then let's kind of talk about, let's see. What is it? I don't recall what was the answers here. A3, we are good with it. B1, we also good with it. C4, we are good with it. And you're right about that. So perfect. We got it right. Thank you. So this is all. Now, quick element on this one, product analysis. Bottom line, whenever you talk about designing and developing a product, your project is about designing and developing a product. Well, very, very basic elements. What do you mean by these terminologies? Conceptually, you should be clear about it. Well, whenever you're trying to design and develop a product for a customer, and that product, well, first of all, I need to understand the product breakdown. When I say product breakdown, I'll talk to the customer about functional requirements of the product. What are those functional requirements? And if you recall from our last conversation, what is functional requirement and the non-functional requirement? Do we recall this conversation? What functional and non-functional requirements? The features that define the product. These are features which are only specific to a product. When I talk about iPhone, we see the Siri thing. We talk about Mozilla, what do you call that? Safari browser, and all those things which are app stores and all the iOS, iTunes, and all that stuff, which is specific to only iPhone. Those are functional requirements which defines your product. They are specific to your product and they cannot be seen anywhere else. That's what defines your product. Non-functional requirements are all those other additional features which needs to be upgraded because that will enhance the quality of your product, which will be the battery backup, the camera quality further, but you probably the screen size and the software and all that additional stuff, which is non-functional one. So in order to design this, there will be two things required. Two things. So you've got the requirement from the customer. You know what is that you need to design and develop. So you need to first of all talk about the designing part. So systems engineering is all about, well, you will sit down with the customer, with your team, and specifically people like in research and development will be required to design and develop and understand like how this product needs to be designed and developed, keeping in mind, they will talk about the feasibility study and they will do all that research work, how these functional requirements have to be adjusted, because you can think about everything, but big question is, can you actually make it? Manufacturability is like one thing which have to be kept in mind. You can think about on a PowerPoint slide, you can make any design, but big question is in real world, is it possible to make it? So the research and development team is more going to look into the part of designing part, well, about like the core design, which is talk about, generally we'll talk about the feasibility study, how it will be done. So the initial part of the design development, how the process design will work to create a product. This is all about design and development. This is pretty much, when you say systems engineering, it's about design and development, which is technically part of the research and development team. Since you have a design ready, you know how it will be done. The team has done some sort of mock trials and everything. They have kind of done some bit of research work. They figured out what needs to be done. Based on this, you have to start the manufacturing and like working to make the product. That's when the system analysis comes into picture, where we talk about when this design development works, will you also have to keep in mind while you're designing it, the requirements of the product. Well, when it works, the process, which is procedures, you talk about like how the work will happen. Well, when you talk about the process is created, this is about the result. Like this is about typically the product, which is getting created. And we talk about typically the design part of it. This is more about the process. When the product will work, what kind of like a process it will go through, and keeping that in mind, because that process, product has to operate within that process, and what all things it should have, what all features it should have in order to work smoothly through that process. So this is typically going to talk about the product, well, who is going to work through a certain process and how we got to keep that process in mind, which will be required to buy this particular product. So I have to ensure that when we are like collecting requirements from the customer, I have to kind of like look into all possible aspects. Well, if I have to design something, I have to know what needs to be done, what needs to be created. Well, is it possible to design and develop and create it, which is about like initial part. Well, you have got a design ready, then you talk about the system analysis, about how the process of design and development will happen and how will you create that product which will deliver the intended output and the process which will be required for that. So when I'm going to design and develop, I will keep these are all requirements. So if I have to design and develop, I have to keep in mind what this product is supposed to do as an intended outcome, what it will deliver. So I have to keep in mind those features should be designed and developed with it, because when you have the product design, it should be able to function the way it is supposed to be done. So if I'm manufacturing a mobile, I have to keep in mind when users you'll start using the mobile, what all features it will be working on, what all kind of activities and process performances it will be doing. Bottom line, I have to ensure that part of the process should also be kept in the requirement process, because if you don't have that clarity, we will not be able to design a product which is about the process. Here it was only about like design and development part, which is more about research and development. This more about creating the procedures, policies, process, how the product will go through. So it's more on those aspects when we talk about system analysis, how it will work in the from a process standpoint. So one was design, another is about process. Requirement analysis talks about more about the customer requirements, which is the requirement documentation we talk about, the RTM part we talk about. So all the customer requirements which are given, you may have to sit down with the team and analyze that. That's more on the requirement analysis. Before we get to this section, it's very important to understand, it's always said in the project management world, anyone can become a project manager. If I have surplus of time, money, and anyone can deliver a project. Delivering a project is not a big deal. Anyone can do that. Big part is, are you able to deliver the product or services, whatever you're trying to deliver the customer in the lowest cost, in the lowest like time, and with a desired quality, which is going to be long-term sustainable quality. So I'm able to look into the cost part. So it's always said like, see, I will be able to do a great job with a great team. A person or a manager is not a great manager who can do a great job with the great people. Anyone can work with great talented, skilled resources and deliver a good job. The best manager is the one who can work with the worst people and create the best output out of them. So similarly, we talk about project part of it. Well, anyone, if I give you enough money, then anyone can do the job. So I'm trying to look at like how can you deliver the product or service from the standpoint of like lowest cost, lowest time, like with a desirable quality, and even the long-term sustainability. Well, the reliability part will come into picture. Well, it should be reliable and sustainable in long term. So that is what we talk about from the standpoint value analysis. So whenever we are going to work, any output which is going to be created, we have to keep in mind the value analysis that we have to do it in an optimized way. My product, the output which is going to be created, it should not be an output, it should be value delivery. Because I may design and develop a house for you. This is the house that I have designed and developed for you. It is just a house, it's an output. When I did the job, you had a house here. But is this house usable for you? If you're not going to like this house, if you're not going to live in this house, then it's not a value delivery. I did create an output. Where every output is a good output? No. So I am not intended, like the purpose of doing this work is not to create an output. The purpose is to create value for the customer. So every output is not value for the customer. So if I delivered something and if it's not worthy enough, if the customer does not like, then it's a waste. So my objective is not about output delivery. My objective is all about value delivery. So I will keep in mind that I should create an output which is worthy, which is valuable to the customer. From a customer standpoint, it's a value addition. And yes, I should be able to do that in a smallest possible, like time duration, with the money aspect, with the long-term sustainability part of also. So it's more about this when you want to, somebody is going to ask you to design and develop a product, what kind of different kind of questions you may ask from them. It's all going to be captured in there. So I want to know what kind of features are there. I will have to look into the requirement from the standpoint of design and development. And when it will work, what all things it should be capturing there. So I have to keep in mind the design and the process also. And then practically I can look at the requirement documentation to get more details. Danish, RTM is requirement traceability matrix. The customer requirements would have been captured there. That's requirement traceability matrix. Quick check on this list if it's okay and clear. All right, let's then move ahead. Let's check this out. Next one. That's where we have to we'll be moving on to Word, like some sort of sketch work, because to understand this is going to be important. So I will be moving out from the slides now. So we'll come back to the slide after we've done some bit of sketch work. This is important to understand. So we'll go to some bit of sketch work, paintbrush. I'm not from the construction background, so please spare me for this. The objective is just to kind of help you understand the work breakdown structure. So let's not get into the technicalities of it, but let's focus on what is being like what we are trying to understand here. So because I'm not the construction guy, I can't give you the exact, probably I may be wrong in there in terms of the core elements. So say when the constructions are done, we have something called excavation, which is done, excavation, which is when you dig the mud out of it. That's the one job I will be doing. Then we will have the structure work. So structure work comes into picture here. When the structure work is done, then we do some services. Services are like a whatever water and like a electricity and all those services are taken care of. Then you have some finishing work which is done. Finishing. Once this finishing is done, then you pretty much like do the handover and all. So I'm just like the handover is here. Now, excavation, pretty much what we do with the excavation is we dig the mud out. That's the only job we have to do here. Well, simply dig the mud out. So you can do the foundation and also you need to have that like excavation job done. So in the structure work, will start with the structure. So I'm saying we have a plan to do two floors, ground floor. So I'll say ground floor, and we have the plan is to do a first floor. When now in the ground floor we have having like the plan is to like the we have two rooms in the ground floor. So let's call R1 for room 1 and R2 for room 2 in the ground floor. Now we have the second one, which is again for the first floor also room 1 and room 2. So here we will be in the room 1. We have got walls to be created. So we have two things to be done. Like basically, let's call it like a wall. We have a wall and let's call it ceiling or like floor and wall. Let's kind of give it like so wall, and which is because you'll have the ceiling because of the wall. So like we have to construct the walls and we have to do the floor. So floor, and this is wall. Similarly, we have to do wall. We have to do the floor for this one also. We have to do wall. And again, people from construction, please bear with me. I probably may be doing it like because it may not be making sense. But again, just trying to get the concepts here, basically what we're trying to establish here. So I'm not going to do for service and finishing and all. What the objective of doing this stuff was to understand the WBS structure. Now I'll change the colors because I need to talk about some elements now. Because if I go to presentation, what we see, it will not make sense. As of now, we need to understand the whole structure. So first of all, we talk about the lowest level because, well, is it going to make sense if I say we do half floor? No. If I say half wall? No. We have reached to the point, the lowest level of this is WBS, the WBS structure. Work breakdown structure. Work is on the top. Excavation, structure, service. You break it down. So lowest level of deliverable that you have here at the lowest level and does not make any logical sense to break it down. This is what we call as work package. Work package is the smallest unit of deliverable, which cannot be further broken down because it does not make logical sense to break it down further. That's what we call a work package. Now let's try to understand. So even wall is a work package, floor is a work package. Now we talk about this room 1, room 2. So let me just highlight this. Room 1, room 2. Same goes for this room 1, room 2. So I'll just do it for one of them. But these both are called planning packages. Planning package. Same goes for ground floor, first floor. These are also planning packages. What do you mean by planning package? Let's understand that. So planning package, basically, it's more of giving a structure. So it helps you to group it together. So work, when you talk about the WBS, the work packages you have here, they are put into a certain group. So if you have planning package, is just about a grouping activity, it gives a proper structure to it. So rather than like putting everything at the bottom, so we know, okay, this is falling into this group and this group. So you know, okay, when you do a ground floor, that's within ground floor, you have to do this. Within ground floor, like you have a room 1, room 2. In the first room, you have again the wall and 2. So bottom line, you're able to have a proper flow or a structure created. So the structure then you create here These are called planning packages. First of all, are they mandatory? Not mandatory. Not mandatory. Wherever the things are complex, it helps you to kind of simplify things by having this planning packages. Because if you just have a work like this is a work package. This is work package. And you see directly it goes above. There's nothing called planning package here. Why? Because if this is one single task, well, why would I have a planning package? Planning package helps you to break it down, put that in right groups. So it helps you to group it and understand and get a clear picture. When there's a simple one task, why would you put it a group here? What are you grouping? No activity. So this is called planning package. Planning package does not have work. Planning package are meant to have a proper grouping and gives a good structure for ease of understanding when things are complex. Because it's not required a planning work package can directly go to the top layer. And what is this top layer called? This top layer from here to here, or all of it, is called control account. Control account. So top layer is the control account. And this is also called management layer, like management level of control. So whenever the management will look at, like the sponsor will come back and check the change control will. They don't want to go and see whether which wall is getting worked out or which floor is getting worked. Nobody wants to know whether room 1 is complete or floor is complete, or nobody has to. Well, why did I hire you then? If I have to get into everything, then why did I hire you? So they always, management review stage is here. This is for management. This is the management review point. So management only reviews at this level. Below this is your job of a project manager. Why should I get into this thing? Bottom line, whenever the review meetings will happen, they will say, okay, buddy, excavation, well, done or not done? Okay, 100% done. Great job. Excavation 100% completed. Structure work, say 35% completed. Okay. Some bit of work, because structure is happening. You also parallel doing some services. There will be similar structure here. Say services done, say 15%. So as when structure is getting done, we're doing service. Finishing, we haven't started here. 0% here. 0%. So management review will happen at this layer. No management will get in the details here. So now all pretty much we got to keep in A. This is called control account. This is the layer for management review. When you break that down, you have planning packages. Planning packages are not mandatory. If you have just like a work package, you can directly go to the control account. But if there's a complex structure, you always give it a proper structure by having this planning packages. And within planning package, there will be work packages, which are smallest unit of work. Now, last bit here, before we can go to the presentation here, it'll become messy, like it become too messy for me to go and write down everything in English literature. So you don't use this English literature, honestly. What do you do here is, let me just go back and pick up a different color, which can be easily identified here. Let's say this is the one. Let's pick up. So what we do here, we do not, in a work breakdown structure, we do not use this because it will become too messy, writing full statements. So we give them code. This is called 1.0. This is 2.0. This is 3.0. This is 4.0. This is 5.0. This is 1.1. This was 2. This is 2.1. This is 2.2. This is 2.1.1. This is 2.1.2. This one is 2.1.1.1, 2.1.1.2. Oh, sorry, 2.2. So basically, what you do here is you assign codes because it will become messy. So you can structure this and you don't write this like labeling thing. You put that in the structure. This is called WBS code. WBS code is written so that you are able to, and no code is duplicated because no code will be duplicated. Each work package will be aligned to one control account only. You will not see a duplicate, the same code repeating somewhere else. No, each code is unique and they'll roll up to one control account. These WBS code are called code of what you can call are assigned, which are done as per code of accounts. Code of accounts, and which simply means that every code, every work package will only align to one control account. So you'll not see these codes getting duplicated anywhere. So typically, when you see a structure, you will only see numbers. And yes, where do you get to see what is the meaning of that number? Because if I see 1.1, 2.1, 2.2, how do I know what is that? there is a separate dictionary created, like a more of a like directory for you. That is called WBS dictionary. In that WBS dictionary, it will tell you what is 1.1, what is 1.2, which will give you all the details about that particular deliverable. So you will, because it right now here it will become messy. That's why we just give the coding structure, and every code is explained in the WBS dictionary here. Let me just quickly go back, and pretty much we're done from here. We can go back to presentation for now, but I will like to quickly check up these questions here. Work package, WBS dictionary, control account presented, PM presented on the valid deliverable. Yes, it is all going to be tested by the management here. Like, so every review will happen at the control account level with the management. Let's have a quick look at this. Now, since we have seen that structure, now this will sort of make us better sense. WBS code, we have got numbering system. We know that each work package is part of only one financial control account. We know now what is a control account. Now, work package is the smallest unit of work which is done at its lowest level. Look at this. It is work package is actually put into a planning package, and planning package goes to control account. Work package can directly go to control account also. If you like digging work, practically don't need it. Directly put control account. Management control point is right. Management reviews everything here. The calculation I was talking about, with the calculation sheet, like I said, we will discuss the calculation sheets that happens at this level. Those calculations, earned value, we will talk about EVM, earned value management. We'll talk about it is done at this. All calculation will be done at this level. This is the role. This from here on, it's all about project manager. Why would I love like as a senior leadership? Well, why would I get into this? My job is to ask this project manager what's happening on the top. I will not get into see like whether your room is done or not, whether floor is done or not. That's your job. You handle it. Bottom line. Quick one here. The WBS code is created as per the code of accounts. Mr. Ibrahim, WBS code is done as per the code of accounts. Remember we have the configuration management system, the coding structure that we have. That's for the company policy, basically coding system. A quick check on this one. Is the WBS okay and clear with everyone? Because we try to kind of sketch everything in this chart. But again, that should have everything here. All in all, whatever needs to be understood from WBS. Obviously, I'm not a construction guy, so I may have messed up things here and there. But again, conceptually, this is what is done. So the objective was to make sure the WBS is understood, not the construction part. Yeah. Okay, let's then go ahead. Let's talk about this. So we go back to our presentation and let's move ahead. So what do you see in the WBS? What we do is you break it down. Let's have a quick look at it. So every deliverable that you have, WBS code is created by, it's as per the company policy. Bottom line, the moment you put that into a software, it'll all start creating those codes and all. So it's as per the company policy. So with the ones who are going to do the job, you align it, it will be assigned. So a certain code. So it will be coming from your software by default, ideally. So identify the deliverables. That's what we got to be doing in WBS, the smallest unit of work, which is the wall, the flooring, that one. And then later on, not right now, the task will be originated from delivery, but that will be part of scheduling, not here. So this will be required to accomplish the task. Basically, you'll have the list of, like at the stage you get to wall, and then in the scheduling part, the wall part will be further broken down. So it will be required later. It helps you to structure and organize the WBS. You decompose the scope into low-level components. You develop and assign unique identification code to each component of the code of accounts. Review the decomposition of packages and verify they align with the project requirement. Bottom line, that's what you do. So you can construct and your WBS. Smallest unit of deliverable is called work package. That's what you have at the lowest level. Now, when you have this done, you also know that is a dictionary. Why? Because this all number system, who knows what is that? So what do you see in a WBS dictionary? You customize yours. Bottom line, it will have all the required details about that deliverable. First of all, what's the code? Say like 1.1.1.2. What is that? I don't know. So the code identifier should tell, okay, what is this? What is the description of work? What are the assumptions and constraints we have already assumed with this particular deliverable? If there is a vendor, contractor who's working on that deliverable, what is the timeline expected for this particular deliverable to complete? What are the activities? Remember, so this is activity will be all, when you do the schedule part of it, activity will be decided. It'll also link up with that. So because it's all done in like a software, it'll all get connected automatically. All associated activities with that deliverable will be there. Resources, because resource management plan will also be required to design and develop your schedule or cost. That will come automatically. Cost estimation, bottom line, everything linked with that. It's because of your software, everything, all different plans you create, and then it will merge and you have everything in one place. Quality requirement, the acceptance criteria related to that WBS, all the acceptance criteria, any technical references, if you have certain guidelines, which are like probably global guidelines, which are there, which can be referred, which are related to that particular deliverable. You can look at that, what a global standards say, and any agreement that we have with the contractor or vendor, that can be explained. So every possible information related to deliverable, which is going to be there, will be kind of explained in WBS. So WBS dictionary has every information that I need about each and every deliverable. So that's what we need. Ideally, we can't write all those things. So we need to have a separate document which gives all the required information. So this dictionary is about giving you complete detail about that work. So once your baseline gets approved, you have, so that's, have a look at this. Approved version of your scope statement, WBS, and its associated dictionary. So the scope statement, the WBS, and its associated dictionary, that will be called a scope baseline, and it can only be changed through change request process. What does it contain? Approved baseline. What does it contain? The scope statement, the WBS, the WBS packages, the planning packages, and the WBS dictionary. Your project's, your baseline will contain by default all of these. The scope statement would have been broken into WBS would have been broken into planning package, work package, and accordingly you have a dictionary along with so all components of your WBS. Quick check on this one if it's okay and clear. Is it fine with everyone? I guess it should be with these things we have kind of talked about already. Now, we got to keep one thing in mind when we're trying to do a discussion with your management and like with your sponsor. We're collecting requirements. We can't just forget that requirements are just not only for designing and developing a product. You have to also look into the transition, handover. If I have designed and developed software and I'm going to keep it with myself, that's of no use. Unless it's handed over to the customer, that job is not done. So we have to keep in mind, if you're designing, developing something for the customer, we have to look into the transition aspect also. So while you're doing, so even transition has to be also kept in mind, because my job is done. I have designed and developed. That's what you're hired for. But even the transition and like transfer is also what I will be part of my scope. So when you're doing the scope, you also got to keep in mind the transition part. So while you're going to transition, who all will be the stakeholders, what will be the timelines, risk and budget and quality standards. Bottom line, you got to keep in mind while transferring this information to the customer. And these are done throughout the project. We just don't do at the end of the projects. As and when something is done, you continue to kind of deliver at the customer end. You try to kind of ensure that, well, although we don't have an incremental delivery option, well, in case of predictive, but in case of agile, you do it. When we kind of do it at the end of every, probably I may have done a sprint 1, sprint 2, sprint 3. 3 sprints are gone and we have a feature ready. Well, we want to do it, deliver it. So you have to understand whether the customer is in the right shape. Well, the customer is so if the customer server needs to be suspended for this update, like you use your banking application, you get a message that your banking application will not be available from this period to this period because there's some scheduled maintenance. Well, what is it? Because they're upgrading it. They're updating some features or something in there. So because there will be some agreed maintenance time or like the downtime will be agreed upon, which we call as special intervals. We'll see as we go forward. Special intervals will be negotiated with the customer as when something is ready and we want to launch it. Well, we don't want to launch like in the end. We keep launching incrementally. So yes, when we do it incremental, well, everything has to be discussed. Well, what will be the requirements? How long this downtime will be there, because customers' business will be getting impacted. So while you can't do this job in a real time, well, remember, think about a situation. We are using a banking application, and at the same time, some real time changes are done. It's going to be disastrous. So everyone's work, every application for that period, the user activity is suspended, and then the changes are done to see whether it's working. The transition happened, great, good job. Now make it live for people. So those will be agreed and negotiated throughout the project. It's just not in the end. We don't just, because it's always an incremental delivery. And if you're doing this delivery for the customer, and you have to keep in mind, let's think. So you say we have designed and developed a software. Well, is the customer already using the software and probably is looking for a better version, which we have designed? So there is an old software already. That means there will be some old server with the customer using. Now, A, is the customer already aware of this kind of like technology or platform? If the customer is aware, well, we got to understand what level of training will be required about this new software, or it's the first time that customer is going to be using such kind of software. So you have to understand about the training requirements. B, I have to understand whether the customer already has the required IT infrastructure or not. If it's not, like if it's not, then I have to ensure that the customer is ready with the required IT infrastructure. That's also part of my scope to discuss that, explore part of it. If it's not there, who is going to do that? If you do not have IT infrastructure which is good enough for you to use the software, we'll have to understand who is going to do that. That has to be discussed and agreed upon. Well, who's going to do? Me or probably some other vendor that you will decide. So if it's some other vendor, then it's out of scope for me. But that has to be agreed and discussed. We have to also keep in mind if there's already an old server they're using, who's going to remove them? I can deploy that server, what we will be placing at the customer end, but who's going to remove the previous one? Well, are we supposed to do that? Well, accordingly, then we'll bill you. If not, do you have a vendor who will do it, or you will manage it yourself? Tell us. Bottom line, we'll have to look into all those elements. Is it a new one or an updated feature? Can you do it? Well, it's not possible. Nobody does that. In live environment, who does it? Nobody idly. How about decommissioning the old systems? Well, who is going to do that? Let's understand that. And yes, the knowledge transfer, the training, the knowledge transfer, frequently asked questions, the troubleshooting guides, and all those things, the trainings which has to be done. So we will have to kind of discuss and understand how to do those handovers. And that is a part of my scope. This is pretty much will be required from scoping perspective. We'll always do that. Let's talk about next one. Okay, we already know the scope part. Well, we already know this one. Incremental delivery is done in the agile part of it, and iterative by default is all part is iterative. We use user stories. Pretty much we already know that part. Nothing new here. And a lot of things will be nothing new if we look at this. We do this planning meetings. We break the scope. Well, we don't use the word scope. Well, technically, in case of agile, we don't have a scope. We have customer requirements, which are in form of user stories. And yes, we have a product roadmap created, and that is broken down to releases. And then releases will be broken down to sprints. So we have a product roadmap which says that this is release 1, release 2, release 3, and release 4. We'll be having 4 releases. Finally, my product will be done. So first release, well, probably I may need say 3 sprints. Sprint 1, sprint 2, sprint 3. Probably for the second release, I may need only 2 sprints. So all we do is like pretty much we have to do the planning at this level. We do a release planning. In release planning, what do we understand? We try to understand how many sprints will be required, how many sprints, like basically when you come to design it, for like you try to understand how many, if you have the product to be developed, you have to understand how many the releases will be required, and each release, how many sprints will be required, what will be the goal date for those sprints, and how long it will take, and all that. Tentatively, release timelines and all, we will be planning that. So that's release planning to understand how long it will take. Probably looking at 3 months time, another 2 months from there, another say 4 months from this one, another 2 months. That's a tentative timeline. And how do you understand how long it will take? That we will discuss later on when we get to that. Agile estimation techniques, the Fibonacci series, we'll discuss about them. So you have a high level idea estimation done, how long this will take. So that is for doing everything done at release level, typically how long it will take to complete a release. And then you know the sprint planning also. By default, you know the sprint one because we've done. So you product owner will be prioritizing the user stories. You will be asking question about the user stories, which is about technically the DOD part will come into picture. The team will like pull the effort, like the word, depending on how much they believe that in the say sprint 1, how much work can be done. So based on the effort, understood, they will pull the item in that particular current sprint, and then they will deliver the job in that sprint. Bottom line, the team decides based on the resource availability, based on the time we have in the first sprint, how much of work can be done. They pull those items after the prioritization has been done by the product owner. They will pull the items in the product backlog, in the sprint backlog. They will have the definition of done agreed, and then based on which they will be doing the job. DOD, definition of done. Definition of done. Designing the app or website in a which stage will be considered sprint or not. Well, the website designing will be done based on the sprint logic only, ideally. So you will be, when you sort of sit down with a customer and you will be having, say, you want to design a website or an app, you will be like, how do you go about doing it? is a flag. So Agile has 50 different methods. You can go ahead and design a website in Agile way through Kanban method. You can use the Scrum method, which we are dealing with. So practically there are 50 plus methods which we have. Well, one of the method is the method that we already discussed, the backlog and all that thing. So you can choose this method of development through Agile way. Is it clear, Mr. Mohammed? So it's not the stage. You decide this is the method of doing it. So what we're learning is about the Scrum-based method of doing the Agile implementation, which has this backlog creation, which has this sprint and all that. So we'll talk about the other way, Kanban method. They're very different ones. They would not have all this stuff in there, because Agile has different ways. Agile is more about mindset, not about. So this is whatever you're going to learn. It's completely based on what the Scrum says. A product owner creates product backlog. We all know already that. Identifies and adds stories in collaboration with the team and stakeholder. Work items, and they describe basically what that feature will do through user stories. Product owner is responsible for prioritizing the backlog. Product owner and the team collaborate to move the items to the sprint backlog. Bottom line, we know all that element. This backlog has different names also. Well, good to know. Requirements backlog, sprint backlog, lean backlog. Bottom line, the most common element, the name is your sprint backlog or iteration backlog for this one. And this is always called a product backlog, always. So iteration or sprint are the same thing. This is called story map. Story mapping is done for all. Whenever the product owner is supposed to prioritize the user story, it's always going to be prioritizing in a decreasing order. Most important user stories right on the top. Second highest important, third highest, fourth highest, fifth highest. So this is decreasing order of priority, topmost, lowest priority. So this story map is created by the product owner. So when the product owner is going to be prioritizing this, it's going to tell us that. And every time, so we have doing the first sprint right now, probably when you do the second sprint, we'll ask this product owner to reprioritize. It's quite possible this user story, this particular user story might become all of a sudden the next time when the second after end of first sprint, this may get reprioritized and become the topmost one. So yes, right now you're doing it, probably that's your order. But next time when you complete a sprint and you ask the product owner to reprioritize, because we'll be doing a sprint 2, your product owner might reprioritize and move a user story up or down. So this is the story map, which helps us understand that which is the topmost user story. So it is created by the product owner. So it's basically help you to prioritize. It's always, you'll see it's always on the top is the topmost user story. The lowest priority will be always at the bottom. This is least priority user story. This is the topmost priority user story we talk about. Story map is more about graphical representation of the prioritization done by the product owner. Let's see. Now, what is the topic called epic? We will first at least talk about the term, what is epic, features and user stories. So conceptually, we should be able to relate with it better. So is it necessary for us to remember who developed this? Kind of no, Ruxana, no. I don't think that would be ever required. No, absolutely not. And that's not our role of a project manager. Who developed doesn't matter, honestly. Now, quick one here. Let's talk about what is this 3 relation. We talk about user story, feature, or epic. Broadly, what is an epic? Under conceptually, we should understand. This is a mega deliverable. Mega deliverable. Let me give you an example. What is a mega deliverable? So that conceptually, you should understand it. Could be a dashboard page, which is a deliverable, and a mega deliverable, which has one dashboard page, has a lot of things in it. Like say, this is one graph and chart coming from some part of my document or server. This part is probably showing me some interactive visual stuff. This part is showing me probably my stocks and shares and everything. Probably this part has some bit of option to log into my email. Bottom line, it's some sort of dashboard. Mega, this different part are coming from different areas. And this image, this is interactive, live kind of dashboard. It's changing. Pretty big, massive stuff. Why? Because a lot of pieces have to be created and then you have a dashboard created. It's a mega deliverable. So in order to have this dashboard done, I should have got all this functionality inbuilt, and then I have a mega deliverable. So before you reach to the dashboard as a mega deliverable, you would have developed this feature, you would have developed this feature, this feature, this feature, this feature. Multiple features were developed, and that's how you have these features working, and then you show the result on a dashboard page. That's how it is. So typically how it works. one or more user story. And typically always more. But again, one or more user story will be required to develop a feature. So if you want to develop a feature, for one feature, you might need just one, if it's a small feature, or you might need lots and lots of user stories to go and make one feature. It's quite possible. So depending on how big the feature is, I may require only one. It's a very small feature. I may require only one user story, or I may need more user story, one or more user story will develop a feature. So when we talk about feature, well, rarest situation, one or more feature, which is one feature that Epic is generally not seen, but you never know. One or more feature will be required to develop a Epic. So Epic is also a feature. Epic is also a feature, but a mega deliverable, which is there. So well, when you go and look at Epic, it's generally a very big, like some very big update. And probably after that, I may go for a release kind of thing when Epic is delivered, when it's probably something substantial, a big element, which can be shown as a change. We can visibly see a big change. So Epic will be generally a mega deliverable. So one or more user story will be required to develop a feature. One or more feature will be required to develop an Epic. And ideally, it's more. So Epics are mega large deliverables, which will be required. It's just not like a small piece of thing. It is going to be something substantial to be able to even release it. That's what the customer will say, okay, well, that's a big change. Something has come into the market. That's how we'll say Epic, conceptually. Ruxana, no, it's the name who developed it may not still be required. Again, from exam standpoint also, it may not be required. It's more about the concept we have to keep in mind, because they are not trying to understand who developed it. History part is not important. Okay, is it okay and clear? Epic, features and user stories. User stories are journal like features there, but all in all, Epic we should be able to relate with better. Have a look at it. We already know this by looking at those videos and all. We have seen this. Continual refinement is done by the product owner, and before the iteration planning, which is before the sprint is planned, because we ask product owner, why don't you refine? Why don't you prioritize? So it's always done. Additional refinement can be done jointly by the team during this. So while the work is going on, it's quite possible that, okay, let's see, we planned, say, 10 user stories, and we're done. We finished the user stories, and the sprint is still pending. So we have, let's say, 2-week sprint. Let's say, like this is like 14 days time period we have. And we are done with the 10 user stories by the end of, say, 11th day. So we have 3 more days left. Well, what will we do? So we can go back and sit down with the product owner, and we can do an additional refinement here. And we'll ask, we got still some more time. We can't end the sprint, because sprint has to end whenever it will end. You can't end the sprint because we planned 10, we are done at 10. So we are done with it. No, you will go back and do additional refinement. Say, okay, we are done with it. We were faster. So now let's go and reprioritize. We got 3 more days left over. Let's reprioritize, and we can pull up those items we can do in 3 days time. So we can plan it out when the sprint is going on. It will be done only in this scenario. Additional refinement, because we never make changes during the sprint. When the sprint is going on, no changes can be done. And this is the only scenario when changes can be done. If my team has already completed the work faster, yes, then I will go, and I can't let them sit down. So yes, pretty much I can go back and tell the product owner, well, my team has done an exceptional job. They've done the job early. And yes, we are okay to go and pull some more items. So let's sit down and kind of prioritize it again. So we can do that. So it allows you to reorganize and reprioritize to work and basically complete the higher priority items to deliver it first. Because every time that you are asking the customer prioritize the topmost. So every time when the sprint is done, please keep this in mind. The most important user stories are getting worked out. So every time whenever sprint gets done, you have the most valuable user story getting created. And that's why it's always the value delivery is happening. And we already know what is Epic. The story from Epic to feature to user story. Split it. Basically, that's what it is. Nothing new here. We already know that basics. I'm not sure. Somebody was paid to just prepare presentations and slides. That's what it looks like. I guess we are good with this. Is it okay with everyone? Quick check on this one. If it's fine, we are done with the scope. Scope part, is it fine with everyone? If it's okay, then we'll be taking a break. We are right on the time. Yeah, looks like, yeah, it is right on the time. Yeah, we're about 2 minutes early. Let's take the break now. We will resume in 30 minutes from now, and we'll come back and start the scheduling part. Another baseline, actually. Perfect. Let's get going now. So before going on the break, we discussed about the scope management plan, the scope related elements. Now we'll be getting into the schedule, which is one more baseline. Now, before we talk about schedule elements, let's kind of high level at least talk about what all we will be seeing in the schedule part of it. So, well, at this stage, if I look at where we are in terms of planning, we've done the first part of scope management plan where we have got customer requirements. We've got, so this is what we have developed so far. This is going to be like more of a summary of what we will be looking into next now. So we have got, let me just change the color. So we have got the requirements from the customer. That's the first thing we got. And after the requirements were captured, we got the scope, project scope statement done. Once the project scope statement was done, we did a WBS, which is work breakdown structure. So that has got all the deliverables at this lowest level, which is where we have acceptance criteria agreed, how the customer will come back and check and audit these things. My team will be aligned with that. Now, at this stage, this is the end of your scope. Now, when you want to start with the schedule baseline, I need to know how long it will take to complete all this work, because that's a scope. Now, for that, I have to go and start with the schedule management. So here we have a schedule management plan, which is one thing, which is again more of a guideline rules, which tells you how the schedule management plan has to be. Like schedule has to be planned. What will be the methods of identifying the right timeline? What will be the procedure, the documentation stuff, and what will be done? All this will be covered in from a rule perspective. But the typical work, what we do here is, in order to complete a deliverable, any deliverable, we have to identify the activities, what all tasks we have to do. So identify activities which will be required to complete that deliverable. That will be done here. So you identify the task. Second, once you identify the task, you put them in right sequence, because if you don't understand the right sequence of those tasks, we will not be able to understand the gaps between them. So there are certain like natural dependencies between the tasks. We have to understand the sequence, right? Once you done the sequencing, you can estimate the duration of those activities. So you estimate the duration, and once you estimate duration, you develop the schedule. So this is pretty much we want to do here. So, but at this stage, we have to keep one element in mind. When you want to identify the activities which will be done to do a job, like say wall is a deliverable. So my activity will be like a brickwork, plastering, painting. These are the activities we will be doing to complete the wall as a deliverable. So we have to put that in right sequence to understand, well, you can do a brickwork first. You can't do painting. You have to do plaster first. When you do the plastering, you have to do painting. So now I can go ahead and estimate the duration. But if I try to estimate duration, well, I know brickwork will take, say, 1 day, plastering will take 1 day, painting will take 1 day. Can I say it will take 3 days? The answer is no. Why? Because after plastering, I have to probably let it dry. And if I put that in right sequence, I see there'll be 2 days to dry. So I can't simply say by looking at a task, when I sequence, I will find the dependencies between them. And there is a dependency that is a 2 days of gap we have to give for the plaster to dry so we can do the painting. And when you estimate, you will have these ideas. But apart from that, you have to keep in mind the risk factors. You're planning certain timeline, but what if something goes wrong? Probably there's a rain. Probably the resource is not available. So, well, because of this, this time might get extended. And this time, how long it will take depends on the resources. How many people are doing the job? If one person is making doing a construction of the wall, or 10 people are doing it, that will decide the timeline. So I will have my resource management plan management plan and the risk management plan already done. So they are not happening in one after another. So a lot of things are done parallelly also. Some people are doing the scheduling part. So people have done this. First of all, we have to do the scope. So when the scope is done, some people will sit down and start doing the detailing about the activities, but some people are also parallelly doing the risk management plan. What may go wrong? People will be talking about the resource calendar and all, because that will be required to us to estimate the right timeline and all. So these are input which will be required to estimate the duration. Let's see all of it, which will be going and planning this out. We'll see all of them. In this section, these are the elements we'll be seeing. So first thing first here, let's go and talk about. So all we have just discussed, we can see all of it mentioned here. In a predictive world, project manager will be the one doing all that job, like this guy is the boss. So work package that you have at the end of WBS will be broken down into required activities. The wall will be broken down to activities. You will be able to, you have to look at dependencies and precedence. Basically, what should be the first activity, second activity, that is sequencing the activities will be done. And based on which you will be doing the activity duration estimation. Estimation has to be done based on average resource management plan should have been done. You will talk about what is a critical path. We'll do a calculation in, well, shortly today itself. So critical path will be calculated, which is basically the longest duration in the project. Basically the duration will be how long it will take is going to be given by critical path. Critical path tells you how long will this project take technically. Resource over allocation, what is that? Say I have a task which needs to be done by this guy. Some A resource is required for doing this task. And the same resource is supposed to be doing this second task, same resource. Well, this guy can do the job. We have only one person doing the job who has the required skill. This guy can do it till here. But now at this stage, we have this guy responsible for doing the two tasks. And well, one guy can't be doing a 24 hours job. So this is what we call a resource over allocation, because it's quite possible one person may be selected for task A and task B. So either I can do a task A or task B. So I have to kind of take care of that issues also while we do the scheduling. And yes, you might, when you're doing a project, if your project gets delayed, then what do you do for like pulling it back, because you have to get it back on track. You can't breach the schedule baseline. You'll have a baseline. So you have to keep in mind, how do you kind of bring it back? The two methods we'll talk about: fast tracking method and the crashing method. Fast tracking is doing the work parallelly. Crashing is the work when you speed up the work by adding more resources. In both cases, we add more resources, but here we do some work parallel. So some extra team members will do the job parallelly. In crashing, we do like by speeding the work. So two people are doing the job. Let's add two more people so the work can be done faster. So we can catch up the whatever the difference has been created. So all this stuff as we go through, it's still an overview. In agile world, well, we don't have anything of that sort. Well, we don't worry about this agile stuff. Why? Because in agile, we have the boxes, which is like basically you will have the sprint box, which is time boxes. You'll have your release, like roadmaps and all that. You'll plan the work in every iteration. That's what you do. The user stories will be prioritized, and well, they will be basically all the user stories will be discussed basically, and you'll have a definition done created. So what all tasks which have to keep in mind. So the team will discuss that and they will do the job. Now it tells you we determine velocity. What is velocity? It's the average user stories that the team is working on. Like, so on an average, how many user stories are completed by a team? So for example, this is sprint 1, this is sprint 2 and sprint 3. So we have done 3 sprints here. So in the first sprint, we completed say 25 user stories. In the second sprint, we completed say 20 user stories. In the third, like in this sprint, we did a 30 user story. So I know my average is like 25 user stories, which I'm doing on an average. 25 user stories are done per sprint, and that's my velocity. So on an average, how many user stories are doing per sprint? And well, we know this part. We work with the product owner to refine the backlog after every iteration. We will be asking the product owner to refine the backlog, reprioritize the backlog. That's what will be done. So typically the same information reiterated, repeated again. Nothing new. Let's see the schedule management plan. So, well, primarily as we go through the project, we will be required to kind of break down those activities. So, well, every deliverable we have, we'll have to break down those activity levels, and those when we keep doing the job, we can progressively elaborate, because, well, things are defined at high level initially. When you go forward in the project, you can define things more accurately here, but you can't define the activities which are in like 6 months from now. So you'll still leave things at a high level for most of things, but as the things as you move forward in the project, you will be able to get more clarity. That's what we call as progressive elaborated, because you will always think things where can be planned and prioritized at a high level, but you will be able to understand the clarity when you get too close to it. So you don't detail everything from the very first one. Estimate velocity is similar to estimate progress. Yeah, velocity basically the average. Like, that's as simple as that. Like Diana, we talk about when you say velocity, it's all about the not about progress. I would say like it's more about what on an average how you're doing. So if you will be able to understand, say for example, let's take a quick example to understand where does velocity part comes into picture, so that we are able to relate with it better. Let's say we're doing some bit of sketching. Sketching will help. So let's say we have got. Let's pick this up. So the velocity part, where does it come into picture? Say we have got a sprint 1, sprint 2, sprint 3, and the plan is that we'll go till say 10 sprints. This is third sprint. The project is supposed to be completed over like 10 sprints here. So if I see that my from my backlog, I pulled the work and we've done the user stories. And like in this one, we did like say there's some say 25. This we did 20. This we did 30. So my average, which is 25 user stories, we are doing per sprint. This is what we're doing. We're maintaining an average. Now, how many more sprints are left to us? We have got 7 more sprints left to complete. 7 more sprints are left over. Now I will look at how many user stories we have in a backlog. So, well, if I look at if I go with this current pace, 7 sprints, and if I'm maintaining 25, so 25 sevens are what are that? What like 175, right? 175 user stories will be completed. So if I maintain 25 for next 7, I will be able to finish 175 user stories in 7. And then I look at how many are left over in the backlog. In the product backlog, I've got 200 user stories pending. Do you think it's a warning sign for me? If in the backlog we've got 200 user stories and I know 7 more sprints are left over, if my velocity is 25, does it tell me something to do? Because at the current rate, I will be able to only finish 175. So it tells me I still have got some time. I have to pull up my performance. I have to increase the velocity. Yes, I have to increase the velocity so that I can catch up the work. Well, because we are doing slow. That means we are doing slow work here. I have to speed up, and that will help me. So velocity helps me to understand how much time is left over. So are we maintaining the right speed? Are we ahead of the speed? Well, which is good. If we can do it job sooner, well, it's sooner the better, because Agile is all about timing. So a velocity will be a very key metric. We'll, in the end, we'll learn about and that's towards the end. I guess last day, we'll talk about burn-up charts. Burn-up charts, their velocity will come into picture. So we use burn-up charts and we'll be looking at velocity. Whatever I just explained here, that will be represented through a graph called burn-up charts. Their velocity calculation will play a role to understand where should we pull up on the work or should we reduce the. So velocity will be a key determining factor. That's what is velocity. So it's about on an average, it will come in handy when you're doing the work. Let's say, perfect. So you will be using some sort of software for this, like scheduling timeline. So you will be using a Microsoft project. You will be using a Jira or a Primavera, whatever. So you may use some sort of scheduling tool, some sort of software for using the scheduling part. And you will have to decide on the format. Well, which would you be measuring the time in case of hours or days or weeks? How would you measure it? If it's a small project, I may measure at hour level. But if it's a project which is for years, I will be probably doing a week-wise. Going at hour level will be insane. When you've got 3 years, 4 years long project, you will rather track your progress on week 1, week 2, week 3, because that makes logical sense. You don't go with. So again, you decide what will be the rate, what will be the frequency of you doing this job. You will establish for developing the criteria, basically while you go ahead and design and like this with the critical path method, which we'll be doing right now, you will be kind of like deciding which method will be used to represent that kind of flow. And there are different ways to represent how long it will take. And we'll see the graphical version of those. There are different options. Bottom line, if it happens, something goes wrong, well, how do you control, which is the fast tracking and crashing, which has to be understood. You can customize this as per your like based on the needs of the project. You can always customize this one, bottom line, and it helps you to understand the progress. Because when we will do some calculation, the Excel file I was talking about, there is a term called SPI, Schedule Performance Index. That can help you understand, are we on track? Are we behind the schedule? Are we ahead of the schedule? Or are we on schedule? So it helps you to kind of even monitor the progress, because when the job is being done, execution is happening as per the plan. Well, we will be able to track whether it's as per the plan, are we ahead of schedule or not. So this some sort of software or tool will be required to be able to do this job for us. So which is typically like a Microsoft project, Primavera, Jira, whatever you're using. See, all these tools are almost the same. It doesn't matter. You learn one tool, you learn bottom line, you understand every tool. It's all the same. The concept is same. Basically, you may have a different brand. That's it. This is all about the tool part. Let's see what is it in the plan. So while you're going to look at the scheduling part, will be just again still an overview what is in the capture in the plan. So you will be trying to kind of capture the different kind of scheduling tool, whatever you want to use for your project during execution. Some sort of tool have to be decided. Well, when you talk about the time part of it, so when you're doing the job from a scheduling perspective, I did mention that risk will play a critical role. Risk has a big impact. Well, because of a risk factor, things may have plus and minus, can happen both ways. So we are talking about building a wall. If there is there's a labor that does not come, so my wall will get delayed. If there's a rain, my wall will get delayed. So risk will also play a role that has to be factored in while you're planning for it. Units, do you talk about right now? Hours, days, week. Well, you will be using the organizational link, basically the WBS structure. Whatever the WBS you've got, and you break it down and to estimate it. So whatever WBS you created, you will be using that to estimate the schedules. Well, when you talk about deviations, this is meant for calculation. The SPI, we talk about the SPI index, we will talk about. So they are related to the calculation. So when you look at the performance assessment, you will be required to understand what percentage of the job has been completed, what is pending, are we on track, are we not on track. So that thresholds part will be coming into picture there. Rules, basically, that is the one we talk about, earned value management. So we'll see the calculations related to. So this is all calculation related. Won't come in right now here. Those calculations will come in later, because this element is part of execution and monitoring and controlling. When not in execution, but when your planning is done, you make a plan, but when the job is getting done, you want to constantly see whether it's as per the plan or not. So there's no task in the execution. You have a plan, you do the job, and you monitor and control through this earned value management, which is technically this metrics called SPI or CPI. CPI is for cost. And yes, the reporting will have to kind of, what kind of reports will be shared related to your timeline. Are we on track or not on track? Daily report, weekly report. And yes, if there's anything which has to be documented about the procedure, how we maintain this kind of process of schedule management. Bottom line, these are generally, again, I said, like all plans will be a set of guidelines or rules, which tells you how my company has been maintaining this schedule. That's it. Again, there's nothing in there. The content, which is pretty much is what we'll be seeing now. How do you come up with a timeline? Well, it's always good to work with OPA, historical stuff. So if your OPA comes into picture, it's always good to look at historical projects done, organizational process asset, which will give you an idea. If you have similar project, will give you a good idea how much time it will take when you're trying to plan an activity, how long it will take. So, but please keep this in mind. It's always recommended that they're good ways to understand, but let's not go blindly with them. Well, bottom line, it will give you good structure. It'll give you good insight, but please look at your problem, and then accordingly, some bit of customization will be required. Do not take it blindly, because your situation cannot be 100% exactly the same. So yes, please look at, you have that information, and then customize. At least you have got some roadmap, an idea ready. So that can be further customized to suit your need. But don't just copy and paste. It will not be a right way to deal with it. So that way, if you have something historical, you can always refer that as a benchmark, which is relatable, and go and adjust your things accordingly. So the good way, any given day, if you have, do you recall what the 4 different methods we talk about? Estimation techniques in Agile, in predictive. 3-point estimation, yes. Parametric one, the statistical one, absolutely. This we talk about 4 methods. Analogous estimation, which is what we have got here. Bottoms up estimation, which is going at granular level, every task level, and then trying to find it. Then we talk about the parametric, which is maths one, like find the cost for one, the time for one, and then do the multiplication. And then the 3-point estimation, which is all about you will go about finding the best case scenario, the worst case scenario, and the most likely one. So those the first one, any given point in time, historical is the best one. If you don't have it, then please go and use other methods, whatever is feasible here. So you can customize this like in a hybrid one. Please keep this in mind. Hybrid is not a separate content. Hybrid is predictive. So predictive part, we know how it works, how you do this estimation. We'll be discussing that. And agile part is very different. So agile parts, do your mix and match. So the part of your project, which is clear and where you're going to be doing predictive, go and apply the predictive method. And which is not like the predictive one, the agile one, you will still be going with your agile, the cadence method and all that. We'll be dealing with that. So you modules are created in cases. So module 1 is probably predictive. Module 2 is probably agile. So I'll handle this predictive way. This I'll handle the agile way. You can't mix and you can do mix and match in your entire product. Create modules and then do the job as per that the way it's been designed accordingly. So nothing specific to agile in this case, honestly. What will come into picture is about the techniques. When we talk about this is what we will be going into. Every project manager is supposed to do this. So what we will be required to do, the WBS work package. Remember the last level was WBS work package, smallest unit of work, which has to be broken down to required activities. When you have the activities, you put them in right sequence, which is what we'll now learn, which is called dependencies and precedence diagrams. You put them in right sequence to understand the dependencies between them. You estimate the duration based on the how many resources are doing the job. You will determine the critical path, which we will be doing in a moment to understand how do you decide the timeline. And same stuff. Look at this over allocation, compression schedule. Will just the same thing. I'm not sure why. Again, they mentioned the same slide here. Same content repeated. Okay. The way you have, remember you have your WBS. This is where we ended WBS. It just tells you the same it's a continuation. Where you left the work package, right at the bottom for every work package. So it's an extension of your WBS. So where your scope ends here. And now you start breaking it down, the activities required. So every work package will have activities. So you can create an activity list, which is a list of activities to be performed in order to complete the deliverable. So it is extension. Where your scope ends, your scheduling job starts. And there we will be breaking down each work package, what all activities are required. And that's how you get the schedule part done. That's why you may create a list called activity list, which is tasks to be performed so that I can complete the work package. Same thing will be extended further. Now, these are important ones, and you always sort of get a question on this section. Now, when we are talking about a task being to be performed, A task, B task, whatever task has to be performed, there are certain dependencies. So the dependencies between the tasks to be performed, or basically when you're dealing with, and these are all predictive ones. Mandatory dependencies are the ones which are by nature. You can't do anything about solving them. This is by nature. Like brickwork will happen first. Then you will be able to do the plastering. And once you're done with the plastering, then you can do the painting. This is the nature of work. The sequence is this way. You do whatever you want. You can't change this. Can't change the sequence. This is the nature, hard coded. This is where it says it must be scheduled this way. There's no way around this sequence because that's a nature. You can't do a painting as a first task. You can't do painting before plastering. Bottom line, that's mandatory because that's how it will work. Now, then comes discretionary, which is best practice. Well, logic says, well, I know that's a mandatory dependency. I will be required to do this brickwork. So that's my wall. So I have done my brickwork here. The brickwork is supposed to be done. Well, this is not how the brick works. Okay, the brickwork is done here. And this is how my brickwork looks like. It's pretty much I do my brickwork here. And then I do the plastering and I do the painting. Then I realize, well, after this job is done, we have to do the electrical work. We have to do the AC duct fitting and also what we do now, we cut the wall. Cut the wall. We do the electrical fitting here. do the AC ducts. Again, we have broken the wall. What we'll do after we have put in the electrical stuff, we'll do the plastering once again, and we do the painting once again. Waste, right? So why this is where we say you can maintain the but this will be waste of time and money. So within this, I do understand when you done the brickwork, do the electrical work here first. Get the electrical work done. So you work when you have brickwork done, break it down, put the electrical stuff, and then do the plastering and painting. That's what is discretionary. Well, it is a choice, and ideally should be done this way because it's the best practice. You can continue to do this way, the way like first go and do the brickwork, plaster, painting, and then break it down, then do it again. But again, logic says no. This is the best way to do it. Discretion is about best practice. These are dependencies between tasks. We have to understand when you put them in right sequence, we can understand these dependencies are there. Like there is one more dependency, plastering when it's done, you have to let it cool off for say 2 days or 1 day or 2 days for you to do the painting. That's dependency. Can't do it instantly. So there is a dependency. For you to paint, you have to wait for 2 days. That's a dependency because you have put them in right sequence. Now, external dependencies are all about those which are outside the project control, like control of the project manager, outside the control of project manager. So these outside could be within the company also, or could be external factors. So my management policies, some sort of guidelines from the client side, could be government regulations. Those factors could have an impact on your project. So we are dependent. So some changes could have been happening at the client, the management end. Management may be coming up with new policies and procedures. So probably they are planning to shift this office location to a different place, but there will be an impact on your project. They are outside your project scope. And apart from that, yes, they could be actually generally the external factor, like the like political condition in the country where you're operating, the economic conditions in the country where you're operating. All those factors will also have an impact, and you have no control over them. Bottom line. Internal dependency is all about your team members. This is when we talk about team members. You're dependent on team members to do the job. They are hired to do a certain task. But now you want to make them a T-shaped team. Remember, do we recall having a conversation about T-shaped team? Anyone? Or has the topic come in? I just want to check.
Yes, sir. Having horizontal and vertical depth of knowledge.
So I want to convince them that they should be doing this job, and yes, these guys will. So I have some sort of dependencies with them, but yeah, I do have a control. Well, as a boss, the bottom line, I need you to do this because say if I have got 4 hours of work, I'll ask you a simple question. I know you're expert in this area, but I don't have like this. You have an 8-hour shift, and the work that you have is only for 4 hours. What do I do? Well, would you be happy if I pay you for 4 hours? Then it's fine. It's absolutely okay. But if you can't, then bottom line, I have to go and train you or something so that you can do the remaining 4 hours of work somewhere else. Because I need to pay you for the entire 8 hours in that case. So here I have some sort of control, obviously, like all the control and predictive because you're the boss. So these are some sort of dependencies we have got depending on activities and tasks within the people. Like bottom line, 4 types of dependencies: mandatory, discretionary, external, and internal. So these are dependencies which we are dealing with. I guess we will be now getting into the calculation part. Yeah. Now I'm going to skip this. I'll go back and come back and show you these slides once again, but after. So I'm just going to keep it here. I think I have shared this material with you all. If not, I will be anyways. I'll put that in today's Google Drive. I will share this material. This one. Instructor material. Yeah, this one. I think I've shared CPM input. If it's not there, anyways, I'll be sharing it. If you will have this presentation with you. This is we could see this in the actual presentation also, but it's not too good to understand and relate with. So we'll like to kind of understand certain things here before we go back, and we can quickly go and check those slides also. But let's understand in a clear way what is it all about. So these relationships we talk. One term, you can see the term which is always reflected here. There are 2 terms specifically rather I'm concerned about. Is one says predecessor, another term called successor. What is our definition of predecessor? Anyone wants to pitch in? What do you mean by predecessor, and what do you mean by successor?
Previous task and next task.
Okay. Predecessor is something we have got talking about before, right? Predecessor means before. And
Yes.
successor means after. Okay. And first thing first, we have to keep this in mind. In English literature, this is correct. But in case of project management, it is 100% wrong. Don't use this word for project management. It is wrong to call predecessor as before, because the definition of predecessor or successor has absolutely nothing to do with your who comes first, who comes second. Absolutely nothing to do. Predecessor can come before, predecessor can come after. Successor can come before, successor can come after. So it has nothing to do with who comes first or who comes later. How do you define predecessor and how do you define successor? That concept we have to keep in mind. Definition of predecessor is one who controls relation. Who controls. Or you can say who drives. Controls, basically, who has a control, who drives the relation. And what is predecessor? Who gets controlled, or you can say gets driven. This is getting controlled, gets driven. So this doesn't have a control. So all the control is in the hand of predecessor. And who is getting controlled? Successor. So any activity, any task which gets controlled is called successor. Any activity which is controlling is called predecessor. So keep this in mind. It's nothing about who comes first and who comes second, because we will see predecessor will come second. Here, predecessor will come second. Successor will come first. Successor, look at this one. Predecessor is coming second. Most of them, you will always see predecessor will come first, successor will come second. But it's not always. Predecessor can come later and still be and successor can come first. So it doesn't matter. It doesn't matter. Actually, it has nothing to do with who comes first and second. It's all about who is controlling relation. So we have to understand about 4 relationships. In the activities, there are 4 relationships. Finish to start relationship is the most common relation that you see everywhere in the world. Everywhere in the world, the most common relation is called finish to start. Well, finish to start, how do you say, well, what is the finish? So here, how I read this relationship. This relation is finish to the, so predecessor is finishing. And when predecessor finishes, successor is starting. So basically, start, how do I read this one? Start of the successor is dependent upon the finish of the predecessor. If there is a delay in the finish of the predecessor, there will be a delay in the start of successor. That's how I read a finish to start relationship. Finish, the start of a successor is dependent on the finish of a predecessor. If there's a delay in the finish of predecessor, the start of successor will get delayed. That's called finish to start relationship. So we talk about most common. I'll give you examples for all of them. Well, let's talk about this one. Let's talk about example also. This is brickwork. This is plastering. That's a finish to start relationship. My bad. Yes, yeah, I can. That should be the right one to change this to black color. You're right about that. So this is a brickwork and that's the plastering. So when you talk about this is plaster and this is brickwork. So when I do the brickwork, pretty much when the brickwork ends, that's when I go to plastering. So the start of a plastering is dependent on the finish of the brickwork. So if there is a delay in the finish of the brickwork, the start of the plastering will get delayed. That's a finish to start. And same will be applied for this also. Plastering will become the predecessor, and this could be the painting part. So again, most common relation is always finish to start. One task ends, another task starts. That's how it's a most common relationship. So finish, one will finish, another will start. Because you can't start the next one unless the previous one is finished. So this must finish for you to start this one. That's the finish to start relationship. We'll come to the last one last, but we'll first talk about this two. Finish to finish and start to start relationship. How do I read it? The way I read it is finish of a successor is dependent on the finish of a predecessor. If there is a delay in the finish of a predecessor, there will be delay in the finish of successor. Similarly, I read it this way. the start of a successor is dependent on the start of a predecessor. If there is a delay in the start of a successor, they're like, my bad. If there is a delay in the start of a predecessor, there will be delay in the start of successor. So bottom line, let's see example. These two will fit in one single question, one single scenario by default. Let's see what that scenario is. There in a software development, there's a person called debugger, like a software tester. There's a tester who's going to do the software testing. And there's a gentleman by the name of debugger, who's supposed to go and solve the problem. So day one, the testing starts. This guy does the testing, finds an issue, and then reports that to debugger. So debugger gets into action. So the tester starts the work, finds the bugs, reports to the debugger, and debugger would start fixing the problem and will report that the job is done. Day two, this guy finds some more bugs, reports to the debugger. Well, he fixes the problem. Day three, he finds no bug. Day four, he finds no bug. Day five, he finds no bug. Well, do you think my debugger can finish this job saying, which we are not getting it, I will be able to finish it? No. This guy, and day six, this guy reports, well, it's been continuously like 3-4 days in a row. We have not found any bug. Now, practically, I declare that the testing is over. We have not been getting any bugs for last 4 days now. So I declare this task is finished. The moment this guy declares the task is finished, that's when debugger will say, now, since I've got a confirmation from the tester, there's no more bugs left. Now I also finish. So technically, the finish of a successor was dependent on the finish of the predecessor. So this guy who's supposed to debug is the one who's supposed to kind of finish the job, but his job of finishing is depending on the finish of the tester. So unless tester declares I'm done, even though this guy is doing nothing, can he or she declare that I'm done? No, because the work is still on. But this guy has to wait for a declaration from this guy that this is done, and that's how this guy can kind of go and complete the job as a finisher. It's finished. In the same example, start of a tester, like this guy started this activity. That's how it started the activity of debugger. So if this guy would have delayed the start, the successor would have also got delayed. So start of a successor is dependent on the start of a predecessor, the one who's controlling it. Who's controlling relationship? The one who's starting it. So if this guy delays that start, this guy's start will also get delayed, because without finding a bug, the debugger will not come into picture. You got to have bugs to solve a problem. So if there is a delay in the start of a tester, there will be delay in the start of a debugger. That's start-to-start relationship. And because you've started with a start-to-start relationship, it'll also end in a finish-to-finish relationship. So before this guy finishes it up, this guy has to declare that I am finished, and that's how this guy can finish. So that's the example for finish-to-finish and start-to-start relationship. Now have a look at this one, the unique relationship. This is the one we talked about, start-to-finish relationship. Here, predecessor comes late, successor comes first. And that's a finish too. So technically, how I will say here, so here practically one which is coming late is the one who is, we're saying, controlling relationship. Can you give an example of something which comes to your mind, which will kind of fit in this kind of scenario? The one which comes late controls the relationship.
Quality check?
No, not in case of, okay, I'll sort of give an example. These are all reliever relationship. Reliever. What are reliever relationships? Wherever you see a reliever relationships, every reliever relationship is there. Okay, there's a hospital, Dr. A, let's assume this one. Dr. A, this is the one who has come in the morning shift. And in the hospital, there are 2 doctors only. No, doctors only. This guy is doing a 9 to 5 kind of job. 5 o'clock, he's supposed to leave. And this doctor is supposed to come at 5 o'clock and then continue the shift. Now, it's 5 already. This guy hasn't come. It's 6 already. This guy hasn't come. Can this doctor leave the hospital without a doctor? No, we can't leave it. 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, this guy comes in. That's obviously this guy is very irritated, but well, then that's when the moment this guy is here, that's when this guy can leave. Although he came late, but he's controlling the relationship. The one who came late is controlling this entire relationship. It's like we talk about a customer service. When you talk about customer service, this is the morning shift which comes in customer service, and the one which is supposed to come in evening shift here. So customer service department, morning shift is coming, and say this company gets everyone in a like company bus. The company bus got stuck somewhere, it had some problem, and it's not reporting time. Do you think that the people who have come in the morning shift can leave for home with the customer service department? Because it's a customer service department, people will be calling in. It doesn't matter which shift is it, but people will still be calling customer service at any point in time. Can the morning people leave? You can't just leave it. People they have to wait for the evening shift bus to come. Until then, they don't come, morning shift has to continue. The guard relationship, the police relationship, people at like a checkpoint, like when you talk about the military, they all have this. Whenever they relieve a relationship, but bottom line, for me to leave the job, well, somebody has to relieve me. Somebody has to come and relieve. So the guards, they do the same job. Doctors, they do. Whenever there's a shift rotation, whenever there'll be shift rotation, it'll be this relationship. So start to finish relationship is all about wherever shift comes in picture. One shift comes in, one shift goes out. Like say, there's a probably some war zone or whatever, some like a national bound, like some boundary. So there's an army which is deployed a checkpoint here. And this is like say one country, there's another country. They are all enemies of each other. So there's a checkpoint. This guy is supposed to be here. So practically he's doing this job at 12 hours shift. And next person is supposed to come and relieve. This guy doesn't come. Well, this guy can't leave the check post. Why? Because somebody has to can relieve it. That's why they will be like some sort of register. This guy will sign, and that's when they will move on. So bottom line, whenever there will be a relationship, when you're relieving somebody, it will be always a start to finish relationship. But again, all in all, most common relationship you'll see always is finish to start. But never say never. You can have all other three relationships which may come in different scenarios. So quick check on this one. Are we okay? Implementing team transitions to support team late. Until then, the support team cannot take control. Okay, give me one quick second. Let me just relate with it. Implementation team transitions to support team late. Okay. Until then, support team cannot take control. What kind of relationship are we referring to? Is this start to finish? Yep. Bottom line, it has to be relieved. It has to, like we said, it's like a baton. Like when you have a relay race, right? It's kind of a relay race. One has to pass on the bait for another to move on. It's a kind of a relay race thing. So yes, one has to let some other one go. That's how it has to work. Now, quick one here. Is it okay and clear with everyone? Because there's one more topic will be coming in here before we go and do some bit of calculations. Next term. Can anyone tell me the difference? What is this term? There's a term called lag, and there's a term called lead. Can anyone tell me the difference between lag and lead? Anyone just wants to pitch in? Like when I order, like so I have a company, there's a company which has ordered some raw material. I need raw material. So I have a vendor which is supposed to supply me the raw material. So there's a vendor, and so when I order on the first day of the month, they supply the raw material on say 20th day of the month. So this 20 days is what we call as this is lead time or lag. Okay. In regular world, so I'm just trying to kind of break the myth from project management world perspective. Like we talked about before and after, here also there is a change. In regular world, even in my lean Six Sigma, this is lead, but not in project management. In Six Sigma also, this is lead time, but not. Here it is, this is called lag. Lag is the delay. Lag is called delay. This is delay. Delay is lag, not the lead. But in a Six Sigma also, in lean, we call it lead time. Every time. So the time I have to wait, we call it lead time, but not in project management part. Well, this is called lag. This is lag, but not lead. What is lead time? Let's see an example of lead time. I have to do this job, and this job is supposed to, like say, hypothetically 5 days time, complete 5 days time. to complete this task will start here, will end here. And it's a finish to start relation. I have got that image, I guess, next one. Rather, let me go to the image and talk about it. Yeah, this is the one. Yes, AJ, you are right about that. That's buffer time. So this is a finish to start relationship. We know that finish to start relationship, first the activity must finish before the other activity starts. So we already know the lag part. Lag is the delay. That's a lag is delay, which we already know now. Now, when you talk about lead time, early in our, like a lean Six Sigma, we say the lead time is the lag one. But now here, lead time is the buffer time. That's a buffer time. And let's relate why the buffer time here. It's a finish to start relationship. So ideally, the predecessor must finish for the successor to start. So when the finishes this, I should have started this activity here. It should have gone till here, ideally, because that's how natural relationship finish to start. One must finish for other to start. But what we have done some work additional, like what? So for example, this was the brickwork which was going on. Once your brickwork is over, that's when you can do the plastering. Well, can you do plastering even before you brickwork? No, I can't do that. But what I know that in the plastering part of it, I have to get the raw material. I have to get the additional stuff like a labor agreement discussion and some bit of prep work, the basic prep work which has to be done, which I would have started this point. I would have done the prep work. So this is like roughly like 2 days of prep work, getting the raw material on the site and getting this like all the labors in. So that was probably 2 days of prep work, which I would have started here. So I'm doing this extra work because I have to wait for the brickwork to get over. So everything else which can be done pre-poned, I have done this extra work pre-poned. So I would have created. Now I will only take 3 more days to complete the job here. Why? Because I have done the 2 days of extra prep work while it was like these things could have been done early. So it's a preparation work which has happened. So I've taken a 2 days of lead time, and that will help me in the future because ideally it was supposed to take 5, and I've taken a lead of 2 days, which will be a buffer time, which will help me in the subsequent project. When I get late, somehow this 2 days will help me because there's a extra buffer I have created for myself now by doing a smart work lead time. Is it okay with everyone? Lag and lead. Lead is the buffer, lag is the delay. Sorry. Let's talk about now. Let's go back to the presentation also first. Okay, lead time is when you're doing the job early, pre-ponement. Let's talk about some bit of work which can be done as pre-ponement of work. Let's see. What can be So ideally, whenever we are doing some pre-ponement of work, so some work which could be done without hampering the flow, because I was talking about something which could have been done. Ideally, I'm supposed to do, when I was talking about doing, let's see where we can do some bit of pre-ponement. Let's take some example where we can do a pre-ponement to explain this one. 2 days of extra buffer work, which we have done early, wherever we can do. Ideally, it's a finish to start relationship. Anything that comes to your mind? Anyone else would like to kind of pitch in here? We have done a pre-ponement.
Can I give you one example?
Please go ahead.
So when we finish class and we announce the exam dates, so 2 days before or 1 day before, we prepare the question paper, printed material, everything for the exam scheduling and everything, no? Arranging the exam hall and everything. So that can be the lead example.
Yeah. Practically, yes, makes logical sense. Well, so ideally say this was probably the class which was going on, and then we would have declared on this day it's an exam day. Practically, we would have declared, and then we would have started the preparation to get probably the printers, the paperwork, and all those things, and we would have started it. But while this was going on, we know this is the work we will be doing later on before we conduct the exam. So that work probably was for about 2 days job, and this could have still been done while this training was going on. We did this preparation work early. So the day the training got over, we were ready for taking the examination. That is, thank you for kind of putting in this. So the things which we can have done, like pre-ponement, things which could have been early without hampering it. Because I can't take the exam before the training gets over. But at least the things which could have been done early, I've done it. So I've just been playing smart here. But thanks a lot for the good example. At least gives clarity. Like a little zoomed up here. Give me one quick second. Going back to this. So the presentation which we skipped, we'll quickly look at what did we skip and why here, because this is the, so remember the definition. Maha, yes, please go ahead. Please go ahead.
So sorry, I just missed the lag. Lag in short is like if the project is for 2 days and it has got to 4 days, meaning that 2 additional days will be the lag, called as lagged, correct?
No, I would say any delay which happens. So basically, I was talking about, so when we do when we talk about the way the plastering is done, and then you have to wait for 2 days before you do the painting. That 2 days is going to be what we call as that 2 days of delay. The waiting time is what we will be kind of calling as a lag. So delay, which is there in between before you start one activity, like one activity finishes and other doesn't start. That gap which we will call as lag time.
But then that will be the part of the planning of the project, right? Like project is for 10 days.
You plan for the activity, you don't plan for the lag, right? If I want to plan for this, and that's what we have to keep in mind. These activities will also have to be thought about when you put them in right sequence. So I know the task, a particular activity we are talking about, how long it will take, but we're talking about that task only. But when you put them in right sequence, we will also understand that that's what we're trying to talk about. Like we also have to kind of understand, because we'll say how much will brickwork will take, how much will plastering will take, how much will painting take. We're just talking about the whole activities. We're not talking about where the dependencies between those activities. That could result in a lead like the lag here, because one activity when it's done, it might need some buffer, some gap before I can resume with the second one. So that will create a lag time. Lag will be there. Lag will be. So if there's a delay in starting the next activity, there will be a lag.
Maybe a sudden rain has delayed the plastering work or something.
Yeah,
like
something has gone wrong. So if my activity does not start, if A activity completed, B did not start, that's going to be lag. Any difference which is lag. It could be risk. It could be a risk because of which it has resulted in lag time. Probably it rained. We were ready, but it rained. That resulted in a lag time. So anything which delays it. Now, quick one here. This is what we talk about. We talk about predecessor, not about who comes first or later. The one who's driving the relationship is the predecessor. One who gets driven is a successor. That we got to keep in mind. Then we talk about the lag and lead relationships. We just talked about that, like basically all those finish to start, start to finish relationship. The 4 types of relationship we talked about: finish to start to start, finish to finish, and the start to finish, the weird one we talked about. And then we talk about lags and leads right now. Just we talk about the gap which gets created, the delay, which is what we call as the extra time which is taken, we call as the lag, and the preponement, the things which you can prepone will be called as lag, because the lead time, because you're able to create a buffer. So while you're doing the job, you don't estimate for these. Please look at this. Lead and lags do not have a value, because when you're actually sitting and doing an estimation, you do estimation about the task, but not in between the task, how much is the time. So that has to be factored in when you put that entire structure in place. You might have to place the differences between them, because when you sit down and do the estimation, you do estimation for the activities. But again, these leads and lags, you have to kind of factor in separately, because ideally they will be not a part of my duration, because I say how much is brickwork time going to take, how much the plastering will take. We're not talking about the duration in between. So that is when we put them in the right structure. We might have to factor in that lag time or lead time on top of it. And yes, that will also be, we have to also keep in mind the risk factors, which will be also added on top of it in my estimation techniques. So which will come in here. So again, there is by default, when we estimate the duration, we're not estimating the leads and lags, because we only talk about only the activities and not the time in between them. So can we say that lead include many lags? Lead includes many lags, but lags do not account lead. Well, that's a pretty tongue twister one. Okay, let's kind of relate with it. Can we say that lead time, which is lead time is when you've taken the extra time, like so we've done it preponement, include many lags? Not sure. Well, I'm not sure. I'm not sure whether how can I relate with that one. So the lead time that you have taken is basically the lead is that extra time that you have taken. Well, if you have done a preponement in that case, may have lags because it's honestly, I'm not able to relate with that. But well, can you give me context? Are you kind of which, if you, in case you're talking about relating with context, lags do not lead to lead time. I'm like, I may have to go and think through this. Well, probably relate with this example. I'm just going to copy this, Mr. Hassan. I'm just going to keep it for now. Let me just go back and think through. Whenever we get a chance, we'll definitely go and think about it. Let me just make a note of it and think about it. If it works, if I come up with something which can probably help us answer this one. Let me just keep it for a moment right now. I'll come back and check this out and let you know if I can relate with something. I don't want to be giving you, because it's like quick. No, this is absolutely fine. This is like, it'll be good to kind of understand. Yeah, it can definitely good to understand. So quick terminologies we would like to kind of go through. And first thing first, there's an important term which will be here, elapsed time. Yeah, it's there. Yeah. So first of all, activity duration, we will be estimating the duration, how long an activity takes, and that could be done in hours, minutes, seconds, or probably not seconds, but hours, days, and basically you have to estimate how long an activity takes. That is basically we talk about estimating duration. But this one, you get a question around these elapsed time, very common thing to happen. So what is this? This is calendar time. So it says that this is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, and Tuesday. Saturday, Sunday are non-working days. Like, so this is off days. These are non-working days. So and the project duration is 7 days, 7 working days. So 1, 2, 3, 4, 5, 6, 7. That's what it is. So I've got 7 working days here. But my elapsed time is 9 days. 9 days is my elapsed time. Elapsed time is for calendar days, starting from here till here. Includes the weekends, off, holidays, everything in it. So elapsed time is about everything from beginning till the end, not the working days. So if my 7 days is the working days, but has a Saturday, Sunday in between, and that will also be counted in elapsed. And actual calendar time will be elapsed time. Efforts are basically how you measure the time. Like basically you count in hours, you count in days, you count in weeks. Basically you decide, nothing is wrong or right. You decide what is easy for you to maintain the log. Basically when you're going to be using a unit to measure the effort, the time, you can use hours, days, or weeks, whatever it is. Let's see quick one here. Estimation techniques, we already discussed about them, but let's quickly have a look at what these methods again, just to make sure we look quickly. Analogous estimation is the historical data. You look at historical data. That will give you an idea to estimate the time, how long it will take. Parametric estimation is about like doing the mathematics here. So find out the cost for one, just go on a unitary basis method, cost per unit method, and that you try to apply that. So if I want to know the cost of building 4 walls, I'll calculate cost for 1 wall, or cost or time, whatever it is, meant for both. These techniques are meant for both time and cost. So I want to know for 1 wall, how long it will take. And then pretty much I'll multiply with all the walls that I have to do. So if I have to do 4 walls, I'll say, okay, for the time taken for 1 wall is this much, 4 walls will take so and so time. 3-point estimation, which is we have already, like in the Word document also, the best case scenario, the worst case scenario. So we use TE is estimated time, optimistic time plus 4 times of most likely time, plus TP is pessimistic time, worst case, divided by 6. That we call as beta distribution. This is also called beta distribution, which is what we ideally use. There's also called, basically, we rarely use an average, which is, which in this case, there is also another way. Nobody uses that, but again, this is best case scenario, most likely scenario, and the worst, equal weightage is given and divided by 3. This is where, this is called triangular distribution. This is called beta distribution. But bottom line, the triangular distribution is nobody uses. All softwares are based on this beta distribution. But again, we should know this one takes everything equal importance to worst case, like best case, worst case, and the most likely are given equal weightage. And that's why divided by 3. Here you give more weightage to the one which is most likely. So this, and statistically, this is any given day more accurate. So triangular distributions are nobody uses honestly, but again, it's a very basic maths of calculating it. Having said that, bottoms up is the most correct way of doing it, but will work for a small projects, very, very small projects. Will be very time consuming. You go at every single activity at a task level and you look at how many people are doing it, what is the daily hours, how you putting it. It's a very, very time consuming one. So bottoms up estimation rarely used for projects. But again, these are 4 different methods. You should know how to estimate. This method will be applicable for time as well as cost. Again, same will be required in this case. Having said that, let's see a quick activity. Do we have real numbers, for example, of 3 points in our Excel sheet? We have used, I guess, not in Excel sheet. We have taken it in Word file, I guess the one I shared. Give me one quick second. The Word file that I shared here, I guess I should have. Give me one quick moment here. In the Word file, we have, I guess, let me just open up the Word file. No, we haven't used the numbers. If you want, like, we can add the numbers here. If that we discussed it briefly, we can just quickly talk about it. We discussed about this, like, let's say, well, I will be going to ask the same question here. Well, I want to travel from the Dubai airport, and I want to from Dubai airport to, like, say, Burj Khalifa. That's what I want to reach. In the best case scenario where there's no traffic at all, how much it will take roughly? Let's just do a quick math here. Roughly about, say, 20 minutes. I guess 20 minutes will be fine. In general, we roughly take, say, like 40 minutes it takes. In a worst case scenario, probably it will take 90 minutes. But that's if we get a lot of traffic. I'll just apply this formula. So I'll say optimistic scenario, 20 minutes plus 4 times of most likely, which is 40 minutes, plus worst case scenario, 90 minutes, all divided by 6. What do you do this? That will be the estimated timeline. Okay, quick one here. That's the one for estimated. Thank you.
So 6?
Yeah, 6 is because you've taken 6 units of time. 1 unit of optimistic, 4 units of this one, the most likely, and 1 unit of, since you got 6 units of time, you divide it by 6 to get a single unit of time.
Okay, sir.
Okay, since you got 6 units of time, you kind of divide by 6 to get a single unit. This is actually, when I look at this one, this is actually this, if I didn't read it, so this is what I read it as. TO plus TM, plus TM, plus TM, plus TM, plus TP, divided by 6. That's what it means. So what, 6 units of time, and that's what I want to find. By divided by 6, it'll get single unit of time. Triangular distribution doesn't make sense at all. Triangular distribution doesn't make sense at all. Why? Because you've got, you give equal weightage to all of them, which is why it's wrong. Because these are rarest scenarios. This is rarest scenario. This is also rarest scenario. You can't give equal weightage to a rarest scenario because that's what is most likely to happen, which is where it will get highly impacted, because this is the best case scenario, quite low. This is the worst case, quite high. So your results will be highly impacted. And that's why statistically it's not correct. This is actually coming from hardcore statistics, which is we call as normal distribution function. It is going to pick up the normal distribution function. I guess there's a question from Mr. Hassan. Just want to elaborate further on that, what you said about leading, like it can follow our successor activity. Let me do one thing, like just copy this one, Mr. And I will kind of go back and check this out, and like I'll let you know, quick one. So whatever you here, you get given here. Just give me one quick second. Mr. Hassan, I will check this out and I'll kind of get back to you on this one if it's okay. I've copied your message and I'll quickly go in and check this out. I'll just park it for later. I'll check this out and get back to you. Okay, perfect. Let's quickly go and check this out. We'll be using these methods. So that's the triangular distribution. This is equal weightage, which is honestly not the right way. We don't use this. Why? Because even no software will be using this. No, none of the software, they use this method. every software works on this, the beta distribution, the PERT method, which is what we will be now using to calculate the timeline, how long it will take to estimate the timeline. So all in all, we are going to now look into the critical path method calculation. So I will be skipping these slides. I'll be going back to the original slides there. So I'm just skipping this slide number 1 here, and I'll be skipping this slide number 2. Is we'll be doing all these calculations, and in the other slide, they're better. So we'll most likely be completing those activities still here. We'll leave it here. For now, we're on slide number 57. Those 2 slides that I have skipped purposefully will be looking at a better version of that. So we have 57. We have skipped these 2 slides, which are about network diagram, and which we will be picking up in that presentation, which we have here. So let me quickly, so we have on slide 57. Let's leave it here. We'll go back to this one. So we talked about leads and lags. So we first talked about this one, predecessor successor relationship. We talked about lags and leads, and now we start about how do you create the critical path method, the estimation of duration. So you first of all create the entire flow. Well, this is your task A, which has to happen. Then after you complete task A, task C will be done. Task G will be done. Similarly, you will be doing task B. Then when you do this task B, then you have to do task. So you kind of lay down the how. Basically, you remember that we have to define, we have a deliverable. For the deliverable, you identify the activities, the tasks, and then you put them in a right sequence. What will happen first? What will happen second? So that's what you have done. And now for every task, you have estimated the duration using any of this method, be it a historical method, which is the analogous method, or 3-point estimation, or you've done like parametric estimation or bottoms-up estimation. You have come up with this estimated duration. So for task A, you have used any of these estimation techniques. You've got a duration that will take 7 days time. That's based on the estimation techniques. This tells you that it will take 6 days time. This will take 3 days time. Same for everything. It has given me the timeline. How did we get this? Based on the estimation techniques. Well, it will take this much of time. I could have used any of the method. All methods are good. Now, how do I plan? How do I prepare the critical path method? How do I get that one? So please look at this. Like first of all, the ES stands for early start. LS stands for late start. EF stands for early finish. LF stands for late finish. First, we will start with the early start. Well, whenever we start this precedence diagram, the early start is always set as 0 because there's nothing before that. It is the 0th day when we're starting. Actually, there's nothing before that. So how early I can finish this task A, because it will take 7 days. So how do I get the early finish? Early finish is calculated as early start plus duration, which will give you early finish. So early start is 0 days plus 7 days. So earliest I can finish this on 7th day. Rule is the early finish will become early start for next. How earliest I can start this activity? The moment this is finished, I can start this act. So if it gets finished on 7th day, if this gets finished on 7th day, I will take 6 extra days. So 7 days is when this task is getting over. So this early finish for this task will become early start for next. So since it's getting finished on 7th, earliest I can start like after the 7th day, and I'll take 6 more days for this. So 7 plus 6 is 13. This will be finished on 13th day. Now again, same rule. Early finish will become early start for next task. This will also start on earliest I can start on 13th, which is post 13th is done. I guess somebody has a message. It will take 8 days for early start for task C. No, we're not adding up. No. Okay, let's let me delete it for a moment and so we start with 0. We start with 0. 0 plus 7 is 7. The day I finish, the early finish of the previous task will be called as early start for next task. So the day this gets finished, I can resume the next task after that. So 7 is the starting point. So 7 plus will be required for this one. 7 plus 6, because it's finishing on 7th. If you start the early, then where do you say 6th day? You'll be counting only 5 days, right? So it's 7 days is when it's getting finished. 7 plus 6 will be 13. So look at this. It's the early start will be, if you put it 8, 8 plus 6 will be 14, which is not going to be correct. We have 7 days for this, and it is so EOD, like pretty much when this gets done, earliest when this gets finished, that's why we say the early finish will become early start for next, because it gets finished, and then 7 plus 6 will be 13, because 7 plus 6 is 13. Look at this, it's exactly the same. Early finish will become early start for next activity, which is 13. 13 plus 3 will be 16. Let's look at the other side. Like we have to go on the dance, this one also. Early start, because it's the first task which is happening, 0. 0 plus 3 is 3. Will become the same. 3. And this task, from this task, 2 tasks are originating. This is originating. This is also originating. So this will also come here. So you consume the entire day. Okay, please keep this in mind. The rule is, when you're making this chart, the rule is the early finish will become the early start of next. And then you add the duration. So, okay, have a look at this. When it's ending, we're saying it will take 7 days. It's a plan. It is going to finish on 7th day. So 7 days, if you're taking for this, and next day is 7, and 6 days for next. So 7 plus 6 will be 13. That's what we're using it. If you use 8 here, then 8 plus 6 will become 14. It'll be wrong in that case. The rule is the early finish becomes the early start for next, because you have to do this plus. That's how your actual duration comes into picture. So early start plus duration is equal to early finish. Is it clear? Like that's how the rule is to use early start as the early finish for one task will become early start for next one. So if I look at all this, plotting this again, I'm sorry about this. I'll just kind of quickly. So this one, 0. This one is 0. Well, 0 plus 7 is 7. 0 plus 3 is 3. 7 will become early start for next. 7 plus 6 is 13. 3 will come here. 3 will also come here. 3 plus 3 is 6. 3 plus 2 is 5. Here, 13 will come here. 13 plus 3 is 16. Now, have a look and please help me understand. This is finish to start relationship. This is finish to start. These two are predecessor. These are happening first. And these are finish to start relationship. So this activity is finishing on 6th day. This activity is finishing on 5th day. Well, how soon I can start this next activity? Finish to start relationship. Remember, the start of next activity is dependent on the finish of the previous one. So even if you're done on 5th day, you can't start this next activity. It has to be 6th only. You have to wait. Even if this task is finished on 5th day, you have to wait, because this task also should complete, because it's a predecessor activity. Predecessor must finish for successor to start. So this will be on 6th day. 6 plus 3 is 9. Now, this task is, these two are also predecessor. Yeah, it's a lag. Yes, there will be lag. Absolutely, yes. And now these two are predecessors for this task. Now that's finish to start relationship again. Well, which one can you tell me what will be the early start? Absolutely, yes. 16th day. Even if you're done on 9th day, well, sorry, can't help you. You have to wait. Why? Because this is going on. It's a predecessor activity. The way this is predecessor, similar, this is also predecessor. You have to wait for this. So this will be 16. 16 plus 2 is 18. My project will take, this duration will take 8. It's not over yet. We have to still continue, but let's get this job done. 18 days is what we know should take for this entire project. But now we'll do a backward cap. Whatever we did right now, it's called forward pass. When you're moving from 0, going till the end, you are doing something called forward pass. So we have done whatever we have done right now. It's called forward pass. So I'm doing forward pass right now. This is forward pass. This is what we did right now. We reached to 18 as the end of the project. Will take roughly, it's 18 days. 18 days will be the critical path. We'll be seeing the critical path also. Oh, well, it just moved too fast. I just clicked on it. Oh, well, let me just go back. Let me go back. Yeah. Now, this is what we have. Now we have to go back and reduce the time, because now the project is, we were moving from 0 to 18. We were taking maximum value because time was increasing from 0 and it was going towards the higher side. So the time was increasing. So we were doing forward pass. We took the maximum value. Now we will do a backward pass, and we'll do a backward pass. We know my project will take maximum 18 days. I cannot exceed that. Now I'll do subtraction. 18 minus 2 is 16. 16, same way, 16 will become the late finish of this one. In reverse calculation, 16 will come here. 16 minus 3 will give me 13 here. 16 minus 3 will give me 13 here. 13 will go here. 13 will come here. 13 will come here. 13 minus 3 is 10. 13 minus 2 is 11. 13 minus 6 is 7. Now 7 will come here. It will be 7 minus 7 is 0. Now here we are doing a backward pass. This activity is merging on this activity. These two activities are merging on one. While we do backward pass, we always take the minimum value because time is reducing. So this will be taken as 10, not 11. While doing backward, we take the minimum value. 10 minus 3 is 7. And that's what we have done. We have done a like subtraction because first we were increasing the values because time was increasing. Now we're going back to do the backward pass. And why we do backward pass? Let's see that. But we just did a subtraction, backward subtraction. Let's see what is it. This is backward subtraction we have done. Let me see if we have one more arrow. Yeah. Now, why we did this backward subtraction is just to make sure we can calculate something called total float. We wanted to calculate total float. This is called slack. This is called buffer. The meaning is same. Total float, buffer or slack. Meaning is the same. What is total float? How do you calculate? Late start minus early start will be total float or slack or buffer. Or you can do late finish minus early finish will be the same. So you do whatever you want. 0 minus 0 or 7 minus 7, 0. 7 minus 7 or 13 minus 13, 0. 13 minus 13 or 16 minus 16, 0. 16 minus 16, do whatever you want, 0. 13 minus 6, 7 days. 11 minus 3, 8 days. 10 minus 3, 7 days. 7 minus 0, 7 days. Now what it tells me, all these values are total float. You can call them total float, you call them slack, you call them buffer, do whatever you want. But this is extra time. Now, the term here we got to keep in mind, all those activities where we have zero float, zero float, zero float, zero float, these activities are called critical activities. These are critical activities. Why? Because there is zero buffer. There's zero extra time on this one. These are critical activities. If these activities get delayed, your project will get delayed. These are all those activities which are critical activities will form a critical path. This is the longest path in your project, and that's your project duration. If you add up this time, 7 days plus 6 days is 13 days. 13 plus 3 is 16. 16 plus 2 is 18. Critical path is the longest path in the project, and that's your project duration, which is 18 days. So my critical path will be A, C, G, and H. This is the critical path, which is 7 days plus 6 days plus 3 days plus 2 days, which is 18 days. That's my critical path. All these activities are critical activities. And if any critical activity gets delayed, your project will get delayed. So these are all critical activities which will make. I missed the name. So critical activities are those activities how do you calculate critical activity? You simply find the duration differences between when you look at critical path, we first calculate the float, the total float. We call total float, buffer, slack, whatever you call this. This is 0 minus 0 or 7 minus 7 is 0. 7 minus 7, 13 minus 13 is 0. So you do subtraction. 7 minus 0 is 7. 8 minus 3 is 7. What it means that this activity has 7 days of extra time. Even if this activity gets delayed by 7 days, your project will not get delayed. Your project will still end on 18th day if this project gets delayed by 7 days. This task also has 7 days of buffer. Even if this task gets delayed by 7 days, your project will not get delayed. This task has 8 days of buffer. Even if this task gets delayed by 8 days, your project will not get delayed. If this task gets delayed by 7 days, your project will not get delayed. Bottom line, these are individual tasks, how much of buffer they have in the total. So these are activities which have float, total float available. That is extra buffer. So while the activities which have zero float, these are the ones which we definitely need to keep in. These are my priority items. Why? Because if these activities get delayed, my project will get delayed, and I may end up breaching my schedule baseline. So it's very important for me to go and ensure all the critical activities are prioritized first. So while if I start my work and these are the first 2 tasks I have to perform, I will have to put all my resources here, every resource here. Why? It's a critical activity. If this gets delayed, the project will get delayed. This can wait. Well, got 7 days of extra time. There's delay. They've got 7 days of extra time. So I can't let it delay because it's a risk. Yes, it will delay my project. My scope, my baseline will get impacted. So first of all, I'll focus all on this one. So this gets taken care of because this can still wait. Well, there's no hurry on this one. While I'm prioritizing this one, this lot, I'll again put my resources here to finish this one because this is a critical activity. And this has still more time on this one, extra time. When I'm prioritizing this, I'll put all my resources here. So it helps you to understand which task needs more priority because they are critical ones. 1 day delay, the project will get delayed. Bottom line, you do not have any extra buffer. These are critical active and they have form a critical path. This is what we call as, how do you know? When you calculate the buffer, which is the total float. So we have a term called total float and there's something called free float. We will talk about what is free float. But before we talk about free float, just want to check with everyone. Is everyone okay with what is forward pass, backward pass, the float, the critical activity, critical path? Is that okay? Now let's talk what is free float. Can there be negative?
Are you hearing me?
Yeah.
I have one question here. It's clear for me the calculation, but in the bathing below, the 7, 7, 7, 8. This is the buffer timing.
Yeah.
If it is consumed, let's say in task B, we consume 7 days. That's mean we cannot consume. There is no buffer remaining for task D and E and F.
Absolutely. It's not that everyone. So one activity has that activity. If you delay for 7, it will not leave any more buffer. But again, you have.
So it's not the summation. If we consume something in the task, it will affect the other tasks.
Absolutely, yes. And that's what we go now. That is what you're going to talk about now is free float. So that is available. So these are available. But if you consume, still will be impacting others. Definitely, it will be impacting others. You write about that. And that's why we want to understand what is something called free float. We've talked about total float. This is total float. But now we have to understand what is the meaning of free float. So you're correct in saying that. And the what you are referring to is actually the free float. Because if you consume, it does impact others. You are right about your interpretation. It will impact. You will not have negative. No, you will not have negative. Time can't be negative, right? You can't be negative, having a negative value there. Now, let's see, what is a free float? The definition of free float has to be clear and then you can help me understand whether it's a free float or not. Definition of free float is the amount of time I can delay an activity without changing or impacting the start of next activity. The amount of time I can delay one activity without changing the start of next activity is called free float. Now, if this task, we have got 7 days of buffer. So if this activity gets delayed by 7 days, my project will not get impacted. We got 7 days buffer. So if this activity is supposed to finish on 3rd day, I've got 7 days buffer. So if I say this activity, I delay by 1 more day. If it ends on 4th day, will it impact the start of next activity? It does, right? Then the next activity will become 4 days instead of 3 days. So this is not a free float because even if I delay this activity by 1 more day also, it will change the start of next activity. It will become 4. It will become 4. So this is not a free float. Now we have 7 days buffer. This activity is supposed to finish on 6th day. So you have got 7 days buffer. If I delay it by 1 more day, do you think this will change the start of next activity? Yes, it will change. It will make it 7 days, right? So this is also not about free float. This activity is supposed to finish on 5th day. If I delay it by 1 more day, will it change the activity of start of next activity? No. I have 1 day of free float. 1 day free float. Even if I delay it by 1 more day, it will get finished on 6th day. But can I delay it by 2 days? If I delay it by 2 days, I can. But will it change? Yes. Then it will change. I have 8 days buffer. If I delay by 1 day, it will not change. But if I delay by 2 days, it will change. So I have 1 day of free float, 8 days of total float. 8 days total float, it can be delayed for 8 days without changing the project duration. But if I delay for 1 day, it will not impact the next activity start date. Now help me understand. Is there a free float here? Absolutely, yes. You got how many days of free float? Mr. Mahesh has already given, yeah. 7 days of free float. So even if this task gets delayed by 7 days, the next activity will not get impacted. This is a complete, like a luxury here, free float. This task gets impacted by 7 extra days. Nothing happens to the start of next activity. So that's a free float. So definition, half free float is how much time you can delay an activity without changing the start of next activity. That's called free float. We have free float here. Now, I would highly recommend, given the time, but like practically, that's what we wanted to cover up today. But there is one more exercise. So you have this file with you. This one is already there. Lag is equal to free float. Yes, the lag that you create, technically, yes, there. And this is the longest path, critical path. And there is an exercise. This is a blank. This has not been done. Do practice this one. So this is not solved. The previous one was, we have already solved this one, but this is a different question. The last one, last slide, the exercise one, this is a new, fresh question. You can try to practice this one also. So the concept should be clear, and try to find where you, what's the float here, which activities are, how much is the total float, how much is the, which activity has a free float on this one. So do check this out. This presentation is there in the downloadable folder. Do check that out, because this is, you might get questions, or like some sort of chart is given, and they might ask you to find the total float there. They might ask you to find the free float there. Yes, you can get questions like that. So do check this out. It'll be easy, and it'll be just these are the slides that we're talking about. These are the ones we had it here, but again, we had more like clarity in those pictures. We can look into it. So we will be starting from here on the project schedule, which is all about like looking at the presentation, how you can present it, whatever software you use, you can present it differently. But again, we'll look into all those tomorrow. So far we'll start from 57. Slide number 57 is where we will stop today, again, given the time. I hope it's okay with everyone, and everyone has this file, this one. It's already there in the downloadable file. I would definitely recommend at least check this out and do solve the last question. It'll be easy to, so just do a quick recap. Whenever you get time, just try to solve this quick maths, and you should be able to understand it. Is it okay with everyone? I guess there were some questions and I parked them, so I'll check them out. I can definitely get back to you tomorrow on them. Let's connect tomorrow. Again, in case you have any question, we can talk about them right now. Yeah.
Sir, excuse me?
Yeah. Yes, sir.
One last question from my side. The free path timing or calculation, it's between the tasks. We cannot consider it for the whole project.
Okay. When you talk about between the tasks.
The free path.
Yeah.
The free float, sorry.
Free time here, like you talking about the free time between the tasks. Is this the duration you're talking about?
Yes, the free float, it is between the task itself.
Yes, this is a
two tasks.
So
we cannot calculate it for the whole project.
No, but this is for the portion that you're doing. Like whenever you're doing this activity for whichever portion you're doing. So every time when you're doing whenever you start doing the scheduling for every deliverable, when you start doing this.
In the previous example, to be specific, in the previous example, we have between two tasks 1 day, and the other task we have 7 days free float. So can we consider we have 8 days free floats? No.
No, it's between two tasks only. So, but for project duration, you're only going to be looking at your critical activity, the critical path.
Yes, the critical path for the project.
That's what is.
Thank you very much.
That's what is important. And this additional task will help you. See, given I have limited resources and I have to utilize my resources in the right way. So I need to know, well, at a given point in time, where I should put my resource, because even if I delay them, that's nothing going to happen. But these will be critical ones. So
the purpose is clear for me, but thank you very much. The purpose is clear for me, but I need more clarification about the free float time.
So for us, the problem is critical path only. We don't have a concern with the other one. Yes, and for how to deal with the critical path is what we'll be talking about. The resource optimization we'll talk about, and we'll talk about this fast tracking and crashing. But again, critical path is what our concern is. Critical path. That's the only thing we're concerned about. These are extra times. We will always utilize them for leveling the work in case we see. So we'll talk about this tomorrow.
Very clear. Thank you very much.
Thank you, sir. Thank you. So let's connect tomorrow, and let's take it up from here tomorrow and onwards. And I guess that'll be all for today. In case you have any questions. All right, then. Thank you, everyone. Please take good care of yourself, and we'll connect tomorrow. Thank you.